Hey, Katie, we're live, so maybe don't share your screen anymore with, with anything you don't want shown to the world. Um, all right, all right.
Good morning, everyone. Just giving people some time to trickle in. All right. Well, we're going to go ahead and kick it off in a minute here. Hopefully everybody's getting their morning coffee in. Okay, we're going to go ahead and get started to stay on schedule for the day. So welcome everybody to SatRday's Columbus. This is our second year of hosting here in Columbus. We're so excited to have you guys here today. We have a ton of great speakers. So we'll have these at the bottom of each slide just so you guys can reference, but we'd love to hear from you throughout the day. There's a few ways to get a hold of everybody here at SatRdays and let everyone know what's going on. So note our hashtag SatRdays_org. Use that on Twitter, etc. Love to hear from you. And then also our hashtag SatRdays Columbus. Okay, can everyone hear me okay? Awesome. All right. So just a few kind of housekeeping items for the day and announcements to let you guys know what's ahead. And thank you all to our wonderful sponsors. And just a little bit about SatRdays before we get started. So SatRdays is a locally run kind of collection of conferences in regional areas that, of course, is part of the R community. And we have some great sponsors from the R community we'll tell you a little bit more about. But overall, for SatRday's Columbus, we had a great turnout this year. So we've had over 175 registrants. We've got tons of wonderful speakers today. And just know that this is a global event. So we are part of 35 plus and growing SatRdays events worldwide that you can tune into, a lot of them virtual these days. So just covered most of this, but it is sponsored by the R Consortium, Linux Foundation, and then as you'll see, Jumping Rivers is one of our regular SatRdays sponsors that we'll thank. Code of conduct. So hopefully everybody knows the drill now in terms of virtual events, but SatRdays in general also has a code of conduct we take quite seriously. So throughout the event, just know that we're providing an harassment-free environment and we want this to be an inclusive experience for all. So note that in your comments and your reception of all of our wonderful speakers we have here today, won't be tolerating any harassment of participants in any form at all. So for more information on that, please check out the hashtag here to get read through our code of conduct. We hope that we can all follow that today for a great event. So a little bit about your wonderful organizers that brought you the day today. So we've got Abbas Rizvi from Tempest Labs. Bernie Lawson works in retail. Ezgi Kareisman, also from Tempest Labs. John Blishak from Freelance Developer, and he's part of our Cleveland arm of SatRday's Columbus. Trevin Flickinger works in insurance. And then myself, Katie Schaefer, also in insurance at Beam Dental. So some rules of engagement. Again, I think we're all a little more practiced than maybe we were last year, but everybody will be on mute. We ask you to stay on mute until we're in more of our QA portion, where we may unmute folks as needed. We are live streaming on YouTube, so you should have gotten the link to that in the email we were sent with all the info, so check us out there. A few ways to Q&A. So we will have the Q&A open on Zoom. Please use that chat window throughout to ask any questions, and then we'll address those at the end. And I believe you can also send questions out in the live chat on YouTube as well. And then, of course, Twitter, we'll try to be monitoring that throughout the day. Also would just love to hear how everybody's feeling about the conference and just spread the good word of the day so folks can log in. Now I want to thank some of our sponsors. So a lot goes into putting on one of these events, and we've got a few sponsors who have been supporters of R and the R community. So first of all is our happy hour sponsors. So we are actually lucky enough to have an in-person happy hour coming after the virtual event today. If you have not yet registered, we'll go ahead and throw that registration link in the chat for you. We'd love to see you all there. We've got a few more spots. The happy hour is free thanks to our wonderful sponsor, Aware. So if you have not heard of Aware, go ahead and check them out. Aware is a great company based here in Ohio, and it works to provide employers and companies insights into employee sentiment and a number of other nuanced things in different applications that companies can use. So go ahead and check them out, and we'll hear more from them throughout the day and then also at the happy hour. I know they'd love to meet you all. Another contributing sponsor is Jumping Rivers. So Jumping Rivers is an analytics company whose passion is for data. They are also one of the certified partners of RStudio. So if you hadn't heard of Jumping Rivers in the R community, they're big supporters. So special thanks to them for the contribution they make to all SatRday's conferences happening throughout the world. And then a kind of a Columbus special sponsor we'd like to thank, Tech Community Coalition. So if you have not heard of Tech Community Coalition, it is founded by Warner Moore. Warner couldn't be with us here today to tell us a little bit more about it. So wanted to share with you all the wonderful things they do for the Central Ohio community. So Tech Community Coalition provides a nonprofit arm and structure for community-run organizations in the tech community in Central Ohio. So they, for us at SatRdays, make things possible like the happy hour by providing us the structure we need to affiliate as a nonprofit and get all the good things that come with that. And then an exciting book raffle that will be happening. So one of our speakers, George Mount, will be raffling off copies of his book, Advancing into Analytics, which is great for all users of R, but especially if you're coming from more of an Excel space. So any audience members who ask questions in the chat will be eligible to be raffled off for this book and the copies of it. But of course, you can head out and purchase this book as well. Strongly encourage you to. Great book, great speaker, and we're excited to have him here today. Okay, so a little bit how the day is going to go. So talks are virtual, happy hour is in person after the event. And so we have broken our speakers out into different sessions. So we'll have a session running till 10:30, take a break. During the breaks, feel free to ask questions, throw yourself video off, throw yourself on mute, which you will be already, and take care of what you need to, refuel on coffee. Then we'll come back session 2. We do have time in here for lunch. And then we hope everybody sticks around for the entire day because we have an amazing keynote coming for you. And then we'll wrap things up and head on to happy hour, hopefully, where we'll see you there. Okay, so you'll be hearing more throughout the sessions throughout the day, but we will start with our first session here. And so I will unshare my screen and kick it off to our studio or our SatRdays organizer who will be introing our first speaker. And if you are the first speaker, Eric, you can go ahead and prep to share your screen.
Thanks, Katie. I'm Trevin Flickinger. I will be introducing our first 2 speakers. I'm very excited. We have 2 great sports talks to kick off the day. Getting us started is Eric Eager. He's based out of Cincinnati, Ohio, and works at Pro Football Focus. They supply data and analysis tools to all 32 National Football League teams and 100 NCAA football teams. As part of their partnership, they provide projections for players as they transfer from NCAA to NFL. In this talk, he'll discuss how he uses modeling tools in R to simulate players' set of future outcomes using a number of different data sources and user inputs. Would you please welcome Eric to the virtual stage?
Trevin, thanks for that introduction, and thank you all for putting on such a great event. As you know, we're all sort of in different sort of seasons in our career. It's so much fun to know that there are these events that we can come together and learn new things. And what I hope to convey here is that there are companies like ours, in the sports, although there's a decent amount of sports talks today, so that's pretty cool, that are using R not only to build analysis tools, but also to put things into production. And this is one of our key sort of products that we're putting in production for NFL teams as well as media entities and the like. So first off, I just want to introduce a little bit of what PFF is. By the way, I have a podcast called the PFF Forecast. It is, I think it's the only football podcast that I get emails from, professors and nerds that actually are closeted football fans that finally like a football podcast. So that's kind of hopefully a fun contribution there. We at PFF have, we've been around for, since the middle of the last decade, kind of living in that startup role for a while now. And then just recently, in fact, this past week, we received sort of our first round of private equity funding. That was kind of a cool thing. We're owned by, majority owned by Chris Collinsworth, who was a former Cincinnati Bengals player. That's why we're in Cincinnati. But is also the color commentator for Sunday Night Football which is really cool because you can see, that's kind of where the numbers on the TV screen come from. And so our mission statement is to use data and ingenuity to provide stakeholders the best possible opinions from which to work. That's different for a lot of different people, but I'm going to show sort of one particular. I'm going to show one particular thing today, and this talk, and there are people here from Cleveland, Cincinnati. Actually, the Bengals are they've won 3 of their first 4 games, which I can tell you is a monumental achievement since moving here. But here's an example of a player that Baker Mayfield, who's the quarterback of the Cleveland Browns. He played at Oklahoma. He had some of the best statistical achievements in the history of the sport in college. And the question was, and the question continues to be, how do you take those performances in one league and project them to performances in another league? And that problem is extremely difficult, and it's rife with things that are and programming in general, and just data analysis can help you with. So here's the big problem. The word is heterogeneity. So for example, a player at the college level might be asked to do completely different things in college than he is in the NFL. He also has different opponent strengths. So some college football players play in really tough conferences. Some college football players play in easier conferences. So how do you level those statistics? Their own team strength is another one. So if you play on a team where you're the only good player, that has a different statistical profile than a player who's playing on a team like Alabama, who has half of their roster will eventually make the NFL someday. Injury situation, athleticism score. So how athletic you are often translates from one field to the next, but oftentimes it masks being unable to play the game well in the first place. Personal background, weather. So again, a player that's throwing passes in Wyoming is going to have a different statistical profile than a player who's throwing passes, in Gainesville, Florida. And then this is the big one, is how the player is going to be used at the next level. So how do you plan to deploy this player? Your projection for that player should be different than a different team's projection for that player. And so just a couple of examples of what I mean by assignments. So here's an example. This player's name is Mekhi Becton. He played down a couple hours from me in Louisville. When we looked at his data, we looked at the number of play types, so play tags, where essentially that kind of play happens in the NFL, and it was somewhere south of 20% of his data. So how do you project a player when he's literally playing a different sport than he's going to play at the next level? Another one was opponent strength. So I'm actually from Minnesota. This is a player, his name's Ben Barch. He played at St. John's in Minnesota, which is one of the most famous Division III programs in college football. So he's playing like a different level of competition than everybody else is. So how do you level that? Another example, this is Green Bay Packers quarterback Jordan Love. When he was at Utah State, his statistical profile changed dramatically when the majority of his team transferred away or went to the NFL. So how do you, again, level those types of things? And this can lead us to, all of these questions and more can sort of lead to us saying funny things, right? So this is Justin Herbert. He beat my Kansas City Chiefs last week. He was NFL Offensive Rookie of the Year. And as you'll notice, 18, 19 months ago, I was not very keen on him as a player. I didn't think he should have even been a first-round quarterback. And so the question, and this is I think very clearly an error at this point. So the question is, how do you build models to sort of get around that? And the answer that we came around. So okay, so here's the end result, which is this is clearly taking a loss for me. The way that you get around this is to build models that can sort of simulate outcomes. So one of the ways is to sort of break the data into what is stable and what is noise. So for example, for quarterbacks, how well a quarterback does when no one's pressuring him is a fairly stable thing. And then how well he does when the other team is pressuring him is sort of noise. So maybe when I'm watching Herbert's college tape, I'm only looking at the things that are kind of noisy, and I make an error in that way. Find out what you want to measure, and then estimate how a player is going to be used at the next level. So how often is his team going to put him in pressured situations, and then simulate. And so here's an example of what we've built, and this is an example of how we used R to do this. We've aggregated all of our data and data from outside sources and wrangled that using traditional R packages like tidyverse, LMER, so forth. We predict player performances in every one of those categories. So for example, how he's going to perform when pressured, how he's going to perform when clean, how he's going to perform with certain weather profiles, so on and so forth. And that uses R packages like Caret, XGBoost, stuff like that. And then you obviously have to build packages to be able to put these into production. So that's, the dev tools sort of stuff that you're going to end up using. And then, productionizing it using things like Plumber. That has been, basically part of our production pipeline here. And we've been able to build tools like this for NFL teams. So this is an example of what we call our IQ product. And this is basically just taking situations for this player. So for example, how often he's pressured, how often he runs play action, how often he makes quick throws, short throws, and we simulate his circumstances given those situations. And so this is a very interesting tool because, when teams are trying to draft or sign a player, there are a couple different ways you can approach it. Oftentimes, you are presented with a player, an opportunity. Let's say an agent approaches a team wanting that player to work for the team. One thing you could do is on the right-hand side, put in how you actually deploy players and then see how he produces. Another way that you can do this is actually, let's say you're going to sign the player. The owner oftentimes will go to the coach and dictate, hey, I want this player on my team. Maybe there are external things like how many jerseys he'll sell, revenue, stuff like that. And you can take the toggles on the right-hand side. So here, for example, I'll make him have less pressure and more play action. It actually changes his projection. It makes him about 0.2 of a win more valuable for your team over replacement. And you can say, okay, well, if we're going to have to play this player, this is the kind of scheme we have to play in order for him to be successful. And you can see how congruent that is with the rest of the players on the team. And you can do this sort of in any other way. So for example, if he throws more downfield passes, so his quick throw rate and short throw rate are smaller than previously, then he'll become even more valuable, about 0.2 of a win more. His completion percentage will go down, but his yards per attempt will go up. And there are a number of other things that go with this, but basically the idea is, this is just R in production. So we are simulating a player's circumstances. We are, displaying, what the outcomes of those simulations are. And then we are, presenting this to our clients as a robust product. So what I think is also cool, and again, this is sort of like the nuts and bolts, but what I also think is cool about R is that we can build things in prototype as well. So one of the things, just as a sort of a sneak preview to this, one of the ways that we've tried to learn how to scout players is to use text analytics. And this is just a bare bones, shiny application, again, as a prototype where we take a player's publicly available scouting reports and we compare them to other players and we build a score based upon that. And, I had not built this prior to making all my declarations about Justin Herbert. But what was interesting was he was the third quarterback taken in the 2020 draft, but he had this composite score that was the highest in that draft class. So our numbers our numbers actually were fairly good for him, but also what trained eyes had seen about him compared him very favorably to other players. So for example, Kyler Murray was the #1 pick in the draft. Josh Allen was the second best quarterback in the league last year. Lamar Jackson was an MVP. The aforementioned Baker Mayfield, I know I skipped Josh Rosen's name. The Baker Mayfield was the first overall pick by the Browns just a couple years ago. So what I like about this is, again, R is a very flexible thing that can be used in sort of robust, production ready stuff, but it can also be used to build really cool, prototype tools for players. So that's about what I have. I think I have a little bit more time. So part of the future solution is, again, more and better data. There's new data sources that are sort of emerging everywhere. A healthy respect for non-stationarity. So again, what's going to win in football today is going to be different than what won yesterday and in the future. And then better accountability. So I do think it's good, like, to go through an exercise like this, which is, how we previously modeled quarterbacks, where did it get it right? Where did it get it wrong? And how to sort of try to make that better. So I think that's all I have. I really want to thank everybody for having me. And obviously I'll take questions. I know there's questions in the chat here.
Thank you, Eric. That was a very wonderful talk and perfect way to get us started today. Please enter any questions in the chat. It looks like we have one already. Where do you get the data, and is it readily available? i.e. pass attempts for QB under pressure versus no pressure.
Yep. So we collect our own data. So we have a team of people that collects data for every NFL and college football game. We sell some of the data. So we sell the raw data to NFL teams and media and actually sports bettors. And then we have a consumer version that you can buy a subscription to our website. So some of it is available. Is it Jair? Person with a hand raised? You're muted. Okay.
Sorry. I can put my question in the chat if you want, or I can. Your choice.
I'm fine.
Okay. So, yeah, I wanted to ask about the utilization of the app and trading up versus down in the draft to potentially get a player that is going to be the best fit for the program or something. So, I guess it kind of depends on like the confidence interval of the projection, but my understanding is that given the variability in translation from college to pro games, as you've alluded to, the analytical solution has typically been to trade down and get more players, so your overall WAR or added value is higher, versus trading up to get a player that has a higher risk factor. Given the sparsity of the data that you mentioned, like that one Mekhi Becton, right, had like 20% of his snaps or less than 20% of his snaps, that could reliably project pro performance. Is that part of how you present this to teams, or is it more isolated as in like all else being equal, you're comparing these two quarterbacks, for example, here's how you might want to make your decision?
Well, yeah, I would say which the analytical finding that trading down is smart is consistent with the approach here, because we're drawing relatively wide confidence intervals, right? So I think rule of thumb is that if you trade up, or like if you look at adjacent players at the same position in the draft, it's something like either a complete coin flip 50-50 that one will perform better than the other, or it's like 51-49. It's not worth the price of trading up. And the error bars would suggest that the wideness of the error bars would suggest consistency with that, which is, you're buying, when you pay up for something, you're generally paying for certainty, and that certainty just simply doesn't exist. And you can look at sort of the differences in means, but in reality, like, you do just have to have a healthy, like, if you trade back for a guy who trade a decent amount of surplus value, and you end up getting, let's say, 90% of the player that you are otherwise going to get, it's probably going to be a win because of differences of price. And there's a really good chance, given the wideness of the distributions, that you're going to end up with a player who's better, right? Just because of the way variance works. So that's a good question. So
do you?
Somebody asked a question about the application of Plumber. That is something actually that is like not necessarily that's something that I would have to ask my dev person. I mostly make the R packages that we produce. So But that's a great question. Honestly, like that is something that is just not something I'm an expert in. How is the data abstraction done? I mean, this has evolved over a long time, but essentially, like we have APIs, and we have basically a lot of like just data frames that we pull out of our database that have basically, so every single play corresponds to something like 250 columns, and most of the data we use is on a very small subset of that, but that's is sort of the basic premise is like every single play we have like a data acquisition tool that we plug data into, and then it produces from that various reports and various raw data feeds that you can use to to make analysis from. And then from there, like a lot of it is data munging, like so basically taking the raw data and trying to set everything so that the roughly the mean is 0 with respect to all circumstances. Do you have to rebuild your model? We do like constantly train it. We do add, different things. There are evolutions in football that require us to either add or take out data every single year. So for example, I don't know, for the football fans here, there was an invention of a play called the RPO, or the run pass option. That was something that had only been a thing in football formally for about 3-4 years. So, when something like that happens, we have to start charting it. We have to add it to our data. So that does cause us to change models. So and the game changes too. So we simply can't just stop training it and continue to move forward. I think we'll make errors. Good question here. So is PFF looking for analysts in data science? You need a sports background. Any data sources get you started. We are constantly looking for data scientists. You do not need a sports background, even though, you don't need one. I think we're really inclusive of people with different backgrounds. My PhD was in mathematical biology before I started in football. So like it was very much a different path for me. But yeah, any data sources. I mean, we do, like I said, we sell a subscription service where you get tons of data with that. That is always a good place to get started. There's a ton of open source football. NFL FastStar is a package maintained by a few friends of mine that's open source, that folks can go to.
I think we're about at time for now. So thank you again, Eric. Please put claps in chat, put the clap emoji to thank Eric for starting us off.
Thank you. Thank you for having me. That was fun.
All right, next up, Andres, if you want to get your screen ready, please go ahead and do that. Our next speaker is Andres Rodriguez, and he is from Cleveland, Ohio. He will be using R and Google Maps geocoding API to be able to geocode the address of European soccer stadiums. Andres, the virtual floor is yours.
Up, you're muted.
Really quick. I was going to say, I think we need to unmute him.
Thank you. So you guys can hear me now. Good? Good. Okay. So as I was saying, I just realized that my PowerPoint is not going to be as pretty as the previous one or the next one that Alec is actually going to go through. It has no memes, which Alec has a lot of memes. They're actually quite funny if you've ever seen Harry Potter. If you haven't, I didn't laugh because I had no idea what they were about. But there you go. My speech, regardless, is about geocoding European soccer stadiums. And just as a disclaimer, I was doing it for European soccer stadiums, but you can geocode whatever address it is you want. So first off, we'll start off with what is geocoding, in case no one's ever, sorry. There we go, gotta go down. So Geocoding is the process of taking an address and converting it to its longitude and latitude coordinate grids. So for example, in here we have Fulham Road, SW6, 1HS, London, England, and the longitude and the latitude. Now this just happens to be the address of the stadium of my favorite soccer team in London called Chelsea. And their stadium is called Stamford Bridge. There's a whole story behind it about a bridge that was built next to it, and it's a whole story, but that's for later. And the way I basically started this whole thing was I had a data set of a bunch of soccer clubs in England and all over the world, and the stadium and the address. And from here, I first started to geocode them in Tidy Geocoder. So Tidy Geocoder has a geocode function in which you simply input what the address that you're trying to geocode is, and then what the latitude and the longitude columns should be called. And I basically call them latitude and longitude, very straightforward. And what you end up with is a geocoded table. So again, it's the exact same one as before. However, it now includes a latitude and a longitude number. And as you can see, there's a couple that are in green that were not geocoded. And this is simply because Tidy Geocoder just couldn't do it. And it was pretty good when it ran it the first time, but it wasn't the entire data set that was able to get geocoded. And yes, I know that the talk is about European stadiums and they have a bunch of like Brazilian ones in here, but I had the whole data set, and before I actually realized that it was not European stadiums, I just basically, who cares? The point is a bunch of stadiums, latitude, longitude. Now, from here, I basically said, okay, I can either go through and try to clean some of these up. Like for example, in this one from Newcastle in England, the actual address has this little thing over here that says to stadium website, because for reference, all this data was scraped, and scraping sometimes gets a little wonky. So I could go through this whole data set and clean it up. However, I just don't want to. So what I ended up doing was actually using Google Maps geocoding API. Now, in case you've never used Google Maps geocoding API, it is a service that Google provides, and you can connect to it with R, and you're able to geocode whatever address you want. And in order to do it, you obviously need to have a Gmail, Google account. And you first need to actually create a project. So you create a project, and it's basically, it shows on your Google Cloud platform. And from there, you actually need to enable billing. So the reason is that when you actually have to like input your credit card and have it on record with them. And the reason behind this is, sorry, just in case you guys can't see this thing on the side, let me move it. Sorry. And the reason is they actually charge you to use their API. So in one given month, you can use up to 100,000 hits to their API, and they'll actually charge you 0.005 cents per each hit. So that's like $5 per every single 1,000 hits. However, they actually give you $200 worth of credits every single month. So you could hit up to 40,000 hits within one given month, and your API is going to be, it's basically going to be free because you have a $200 credit. And from there, you also need to create an API key. Now, this API key is it's basically a random string of text and numbers. And you obviously treat this like your social, because if anybody were to get a hold of it, they could use it, and you would be charged for all of the usage that they end up having to do that they use for it. So again, treat it like your social if you would. And from there, you simply use ggmap. Now, what you first have to do is to register Google your API key. So you simply input it in there, and it registers, and it's good to go. And then you basically use the mutate geocode function from ggmap, and you insert what the actual data set that you're trying to geocode and what is the location address that you're trying to actually use. And from there, it basically runs through the whole data set and it geocodes everything. And you might be wondering, how good is GGMap compared to Teddy Geocoder? And when I first ran this, I had 2,651 addresses that had geocode. And Teddy Geocoder, as I mentioned, was fairly good. It was 73% hit on all the ones that I had. Once I went to GGMap, it was virtually all of them. It was like, there was a couple that they couldn't geocode, and I even tried finding the address and it was like, I couldn't find anything. So it basically geocoded like 99% of all the addresses that I could throw at it. In general, like, you could use Teddy Geocoder and fix up some of the addresses. I personally didn't want to. I just wanted to just get it done and geocode it and be done with it. And this is actually a part of a larger project that I'm working on. So I'm sure you guys, I don't know if you've ever heard about gravity models in physics. And the concept is that you're able to actually calculate the gravitational pull between objects in space. So for example, you can actually calculate the gravitational pull between the Earth and the Moon. And as we know, there's gravitational pull because the Earth and the Moon are fairly close to each other. However, there's not a gravitational pull between the Earth and the Moon, Earth and Jupiter, because Jupiter is so far away, but Jupiter is also bigger than the Moon. So if you actually go down the whole rabbit hole of gravity models, it's a function of how far away the actual objects are and how big they are, right? Now, this whole concept was applied in the world of international trade in economics, where you're able to actually calculate the trade between countries from all over the world based on how big they are and how close they are to each other. So for example, if you think about the trade between the United States and Mexico, that trade is going to be higher than the trade between the United States and Germany. And that's because obviously Mexico and the United States are right next to each other. However, if you think about the size of these countries, and in general, in the world of economics, we measure them in GDP. The GDP of Germany is way higher than the GDP of Mexico. However, again, as I mentioned, the United States and Mexico are right next to each other, so it's very easy for them to trade with each other. And this whole concept, I wanted to apply to soccer, and I just couldn't figure out how. So what I actually ended up coming up with, like last summer when I was like bored because COVID gave me nothing to do, I basically came up with a gravity model of international trade for soccer players. So in Europe, the way soccer players work is you can actually sell a player from one club to another and you pay money for them. And this is done, you can do it all over the world, but I specifically focused on Europe. And the concept is that, well, if you have a player, for example, right here that you see in blue, they are going to sell it to another player, another club somewhere in the world. Well, if you create the actual model where the distance between the soccer stadiums, hence why I need to actually geocode them so I can calculate the distance between them, is a part of the equation, but also the size of these clubs. So for size, I just end up using the position in which they actually are in the club tables, in the league table, sorry. Sorry, there's a little thing on the bottom that messes me up. Wow. But the whole premise is like the actual price you're able to sell a player for is a function of how big, how good the club is and how far away they are from each other. And I didn't put up my results because I was like literally doing some stuff. But it's actually, when you think about it, like we're saying that there's more trade between the United States and Mexico. In the world of soccer trades, it's the inverse. The further away that you actually are from, the further away the clubs actually are, the higher the selling price that you actually sell that player for. And intuitively, that makes a lot of sense. So for example, if you're in England and you're not going to sell your best players to another club in England because you play in the same league. So you're going to be selling a player who's really good, hence they can actually sell for a higher price, and you would be selling it to your actual competitors. You wouldn't do that. You would try to sell him to a club that's further away from you, so that they're not going to be in the same league as you. If you're trying to sell your best players who are going to actually going to sell for a lot of money. If you really, really want to know about this whole thing, I may be doing a talk in our Cleveland R meetup in December. So if you want to know more about this, you can go to that talk. But conceptually, this is the whole premise of why I was even trying to geocode the address of European soccer stadiums. And I realize I have 10 minutes left. So I can take questions for 10 minutes, or I can give Alec 10 more minutes for his speech. Thank you.
Thank you so much. Thank you so much, Andres. It looks like we do have one question in the chat. Was there a difference in accuracy? Did it geocode by address, rooftop, driveway?
I tried actually checking a couple, and there is differences, right? It's not like they're the exact same. However, when it comes to geocoding, it's like, what's the difference between, these stadiums? They're not like, it's like trying to geocode like actual stadium. It's like, where do you actually put the pin on the stadium? It's like the front and the back. You could do it down the street a little bit. It's like, there's really no like, yes, there's differences, but it wasn't like significant that I was ever like, oh, this is completely off the charts. So yeah, it's small little differences. Any resources on getting up with Google projects? Yes, I actually have some links that I actually use myself. So I'll provide them in the chat when I'm done speaking. When you say gravity model, is there something unique about the distance calculation? Yeah, so when we talk about distances, if you think about like what's the distance between Cleveland and Columbus, you could do a straight shot, or you can actually try to calculate like the distances between like all the, like, it's not like I do the bird's eye view, but you could literally do like the way Google does it, where it takes all the considerations of the streets and stuff. I don't do it. It's just like, here is Madrid, here is Manchester, here's the actual distance as a bird's eye view between them. Is there other things you investigate for distance, cultural, and language similarities? Yes, so when we generally do international trade models, you take into consideration, for example, regional trade agreements, or if they're right next to, if they share the same border, if you, what's another thing you consider? If there is anything that's culturally different. This, however, is a bit different because we are trading players. So the way I like to think about it is, or the currencies, right? For example, you can say, what is different currencies between all these countries if you're comparing euros versus US dollars versus pesos and whatever. They're all in the European Union, so they're all technically euros and pounds, so there's not much variance. And they're all technically touching each other, unless you talk about England, which is an island, but then it's like one country versus four. Sorry, I forgot to mention that I was doing England, Spain, Germany, Italy, and France. So it's not all European, it's just those five. And yeah, then I haven't really finished the whole project. I literally, when John told me about this, I was literally building, so I'm like, here's something to talk about. And then, any experience using organizational account with Google projects? So another question is, any experience using an organizational account with Google projects? Strangely enough, I will, starting on Monday, because basically I work at Progressive and I transitioned to another group in which they actually use Google platform to do like web analytics. So I'll let you know in about a month. And then the question is there any good textbooks on international trade models? There is, but they're all very technical. Like, nobody's gonna write a book on like, here's the fun part of how, the international trade for layman's term, like nobody's going to do that. There is books that like I used in college about international trade, but they're like this big, and like there's like more math. There's like more math than equations on any page than actual words. So thank you. Any other questions before I give it over to Alec?
Andres, I am curious, maybe what other solutions you found when looking for a tidy geocoder replacement besides ggmaps, if any.
I honestly, I just want to Gmap straight. It's like I've kind of personally gotten to the point where I'm like, I don't want to figure this out. I just want to get it done and move on to the actual project itself. Like I don't want to spend my whole time trying to figure out how to easily geocode. Plus, it was like I was hitting 2,000 geocode hits. I'm never gonna reach the $200 limit, which is 40,000 hits. So I was like, get this done, get it done, and move on. Thank you.
Any other questions from the audience? We'll give it just one more moment.
Thank you. But again, this is like, it's like something I've always wanted to do. Like I've always wanted to do trade models with soccer. I'm like, how do I do this? How do I do this? And I finally figured it out last summer because again, I had nothing to do. And then I basically took it down to the point where I'm like, I'm actually trying to get this published as a paper, but it's still not at that point. I'm still at the draft version. So thank you.
Awesome. Well, thanks again. It looks like there's a lot of interest in the chat. So maybe you can hit up the next Cleveland R meetup to learn more. All right. Thanks, Andres.
Thank you.
Bernie, I'll let you take it away for introducing the next speakers.
Awesome. So our next speaker will be Alec Wong, returning for a second year of SatRday's Columbus. Alec, if you want to go ahead and bring up your screen, I can introduce you and your presentation.
Sure thing.
So Alec enjoys applying R and statistical analysis in his work in the insurance industry here in Ohio. He affectionately pitched us this presentation as sometimes you need to speak in the language of the snake. So Alec believes that becoming proficient in both Python and R is a really critical skill in today's analytics landscape. And he's going to talk to us about a package that our studio has written and supports called Reticulate. And I believe you're going to tell us about some ETL procedures that you've written and support. So take it away, Alec.
Thank you, Bernie. As Bernie mentioned, and Andres as well, I work with Andres. We work at Progressive here in Cleveland, Ohio. So sorry for intruding on your Columbus space. Okay, so first I want to get a reaction from everyone who knows the main theme to Harry Potter. How does it go? Just throw a reaction if you know it. Nobody knows it. Okay, anyway, browsers have seemed to disable the ability to autoplay music. So for those of you that do know it, I want you to keep that going in your head as I give this presentation. Okay, so what am I going to be going over today? Just to set some expectations, we're talking about the package Reticulate. And this lets you use Python code inside of R. And what we're going to do is we're going to go over some of the basics of how to use this package. We're going to look at some code, and then we're going to see that it worked example that I put together. Let's see, I would like to get rid of this. Okay, perfect. All right, Arthur C. Clarke says, any sufficiently advanced technology is indistinguishable from magic. So for the next 15 minutes, Reticulate is going to be indistinguishable from magic for us. And here we enter the world, the wizarding world of R programming. So my wife and I are reading through Harry Potter. This is my first time reading the books, actually. And I felt that this theme was appropriate if a little unoriginal. And this webcomic is pretty old, but if I might take some liberties here, if Harry is speaking Python, that means that Gryffindor speaks R by default. So getting to the package, it's called Reticulate. You can get it by just running install.packages, Reticulate. And what are the benefits that come with this package? Our studio develops it, so you know that it'll be supported and well maintained. You can use the REPL or the Python console directly in our studio. It lets you convert Python objects into R objects and vice versa. And you can view your Python environment right from your environments pane. And you can poke and prod the stuff just the way you would R objects. And if you want to, you could stick with R syntax. You don't have to learn a whole new syntax. You can stick with R syntax and just work with what you're familiar with. And for those of you who haven't used Python before, what this package is really great for, one of the things it's really great for, is letting you continue to use what you know, what you already know. You know R, you know how to use R Studio, you're comfortable in that environment. And so this is kind of like training wheels if you want to get started within Python. So I am going to take a minute and talk about getting set up very briefly. So I typically use Conda to handle my Python packages. What is Conda? It's a package management system for Python. And so it can give you a version of Python and then packages the same way you would get them from CRAN. And then I use environments. And environments are just a way to minimize package conflicts between your projects. I can start with a clean installation of Python and then get any packages I require. So here on the first line, I'm loading the package, Reticulate, and then I'm querying what environments do I have present. Let's say I don't have the environment I want. I can create it using this function from Reticulate conda create. And then I can specify I want Python version 3.9 and then pandas 133. I don't have to specify a version, but I'm just showing you that you can. And then we tell Reticulate that I want to use this particular environment. And I want to make sure that you pass required equals true, or else if you don't have that environment, you're going to end up using the base environment. And who knows what your users have installed in their base environment. So you want to make sure that you include that. So once you've specified where to find Python and all that, you're ready to go. We can start using Python directly inside of R. We can start what's called the REPL or your Python console to do things just as you would in the R console. And I don't think that this slide does it justice, so I'm going to show you what that looks like. If I start REPL Python over here, it loads up a Python interpreter, and I can do anything I want in here. So I'm going to say my directory. First, I'm going to import the OS module, and then my directory is OS lister. And now I see that I have an object in here that lists stuff in my directory. I can leave this at any time by typing exit. But here's the cool thing. When I start the REPL again, the stuff is saved there. So I can flip back and forth between R and Python and take the most advantage of both of those environments. I can use Python in R Markdown. This on the left is native Python code run inside an R Markdown code chunk. And I want you to contrast that to the right. This is how I would do it in R. So on the left, I'm importing the platform module, and I'm querying what kind of system am I running using the platform function. I get Windows. On the right-hand side, I'm going to do the same thing, but using reticulate functions. Reticulate has a function called import that does the same thing as import on the left. And so I'm basically saving this module into an object called platform, and I'm calling the platform function from that module. And I get Windows again. And just a note that the $ is the equivalent of the period. If anyone's familiar with R6 object-oriented programming structures in R, they also use the $ to access attributes and methods and so forth. And I want to show you what this looks like in our studio. Okay, this is how I tell R Markdown that this is Python code, and it's meant to be run in Python. Is I include Python in the code fence language specification. Normally you see R here, but you can include a lot of different things in here. There are engines for SQL. You can run shell commands. You can run Julia even, I think. Lots of different stuff as long as the engine's available. And Reticulate provides the engine to run Python. I can access Python stuff from R. So with this first command here, I'm running an arbitrary Python command. I'm importing NumPy, which is just a package, and I'm giving it an alias. I'm going to use np to reference NumPy. And then I'm going to run this other command, creating a range of integers from 1 to 9, and saving that in an object called vec. Reticulate provides this object called py that will look inside my Python environment and pull out anything I want, converting it on the fly into an R object. So if I look at what pyvec looks like, it looks like a sequence of integers from 1 to 9. But how do I know it's an R object? I am going to create the same object in R. We use the seek function, seq, 1 to 9. And then I'm showing that these are all equal. They're the same thing. I can go the other way as well. I can access R stuff from Python. So I'm going to load the CO2 data set, and this is built into R. I can just call data CO2, and I get the data frame in my environment. And Python has an R module, the same way we use the py object over here. There's an R one on the Python side. So I can get stuff from R for use in Python. So this is Python here. I can call r.co2 to grab the CO2 object that is in my R environment. And I save that to this data frame in Python object. If I print the first five rows, I see that, yes, indeed, I've got the data frame, and that's the CO2 data. And since I have pandas installed, it converts it directly to a pandas object, a data frame object. And then I can go back. I can take that CO2 data set that I've now converted to a Python data frame and then take it back into R. And it's the exact same data. As you can see here, nothing's changed. In fact, behind the scenes, this the factors are maintained. So these are not just strings, they are factors. And I believe that plant is an ordered factor, and that's maintained as well. There's equivalent structures in pandas that allow us to keep exactly what the data structure is of each of these columns. And that's really cool. We're going to take this even a step further. When we start using reticulate with dplyr, sometimes you don't even notice you're talking Python. I have an example of how I put this to use at work. I have an ETL routine, something pretty straightforward, but I needed to use Python for it to work. Why? Because I needed to query from some Microsoft OLAP Cube databases, and I couldn't find anything that did that in R. Maybe that's an opportunity for someone to write a package. But I found a package in Python, py80omd, that lets me send queries and return data. So I essentially just wrote a wrapper around py80omd with a bunch of additional functions to handle the query and transform the data. And then I used R again, because I can't find anything in Python that comes near to the convenience of the DBI package when interfacing with SQL Server. So I use R to upload back to SQL Server for convenient access of the data. So I'm going through the whole thing again, except now with the worked example. I'm using a Conda environment to make sure that I have all the right packages, Python packages that I want. And then I'm importing a package. This is the package that I wrote that performs the queries into R. And so this module has all of the Python functions and classes and everything that I put in there, except now I can access it from R, and I can integrate it into my workflow. So I'm pulling out the Foresight class, which has a bunch of methods, and it has a connection object in there. And then I'm pulling out 3 functions that are inside the module. And keep in mind, these are Python functions. There's no R inside those functions. And this is a stripped down version of the ETL workflow. But the first thing I do is execute the method from the Foresight class that performs the query. And I get a data frame back, an R data frame. And then after that, once I have the R data frame, I put it into a dplyr workflow. And so in the first line, the first transformation, I have add year month columns, a Python function that's in the pipe. I have a mutate step, and then inside the mutate step, I have 2 more Python functions, convert state code and match WM line coverage. And these are operating on R columns of the R data frame. And these functions, they just work. I was surprised, a little surprised, but maybe I shouldn't, because the developers at our studio are nothing short of wizards. What makes them work, though? Very basically, let's take a look at the definition of this function. There's nothing complicated. I could have written this in R. I was just a little lazy. I already wrote these in Python, so why rewrite it, right? So generally, for use outside of a dplyr verb, so this is in a pipe chain, but it's not inside a dplyr verb like these are. We want to, the general advice is try to operate as R would. And the basic idea here is we take a data frame, we perform a deep copy of the data frame. Now, pandas will occasionally modify whatever you pass into this argument outside of the function scope. R doesn't do that. So to ensure the same operations, I'm taking a deep copy here. And then I perform some transformations, and I return a modified copy of the data frame. And that is enough for it to fit right into the pipe workflow right here. Of course, like most tidy functions, you want to keep the data frame as the first argument. And that's how you keep the pipe going.
So Alec, this is really great content. I want to give you a choice. We have a lot of questions coming up in chat.
Oh,
we have
okay.
5 more minutes that you can go through. This content is fantastic, sir. People are blowing up the chat though.
Oh my goodness.
One thing we could do is you could go through another 5 minutes of your presentation, then answer questions in the chat and on Twitter. Or we could pause here and do sort of a facilitated Q&A. What do you want to do?
I'm just going to run through it. I don't have many more slides.
Awesome.
A couple of slides at the end are just joke slides. So thank you. I will speed this up a little bit. For inside of a dplyr verb, once again, we have these 2 functions that are inside of a mutate step. All this is doing is this is a lookup. That's all it's doing. But the bottom line is it takes a vector or a list in Python and it returns a vector. And reticulate handles the transformations automatically. And I can't stress enough that this is just magic. This is amazing. So a couple of caveats and considerations. For those of you unaware of how funny this is, Gilderoy Lockhart casts Obliviate and promptly forgets everything. So don't be him. Make sure, I just want to throw these out there. I use required equals true when using, when calling your conda environment. Otherwise, you might get some random environment. And export your environment to a text file. Reticulate doesn't have a function for that yet. But so you'll have to use the command line to do this, but here are the commands to do that. And then here's a list of all the items that are transferable between Python and R. All right, thank you for listening. Give yourself 500 points. And here are some of the resources that I mentioned. And okay, we can get to the questions now.
Alec, I gotta say, you do a solid presentation, sir. 2 out of 2 for years at SatRday. That's awesome. I know the first question I want to bring up for you is Katie had asked a question in chat that I was also curious about. When you think about like, how did you, so in this use case, it just wasn't available in R. So that's why you brought in the stuff from Python.
Mhm.
What's your decision process in other scenarios when you would go to Reticulate to bring something into Python? Talk to us about that decision process.
I think, well, personally, I enjoy R the most. So of course, I'm going to be writing most of my stuff in R. But I think one thing that Python does better is string operations. I haven't done a lot of benchmarking, but I think that the RE module in Python is a little faster than at least the base functions in R. So if I was doing a lot of string operations, maybe I'd make use of Python to, if I'm doing a lot of regular expressions or something like that, I do that. Of course, the whole reason Python is so big is because of the machine learning capabilities, right? So a lot of stuff has been moved over to R. We have Torch now for neural networks, and XGBoost is available, and LightGBA. All the major ML packages are there. But maybe you want to use something that Python has that R doesn't. You can do your data processing in R and then just pipe it over to a Python function, and Reticulate will take care of the transformation for you. Oh, Bernie, I think you're muted.
Oh man, I muted myself. Oh, gosh. So I was going to say last question, and then we'll go over to Mike Sovic, who's going to talk to us about SARS-CoV-2 variants and mixed samples. When you save a file that you're developing in RStudio that uses Reticulate, is there a different file extension on that?
No, it's an R file.
Awesome.
Yeah, you can use your ordinary R or R Markdown files. Yeah.
Awesome.
One thing I will mention is if you're trying to debug a Python function, you probably want to drop to command line or Visual Studio Code or something like that, because the utilities for debugging in Reticulate aren't fleshed out yet, I don't think. But somebody correct me if I'm wrong.
Alec, it was awesome hearing from you again. Next year, I hope you bring this A game. I don't know how you're going to top yourself again. So awesome.
Thank you so much.
So, Mike, if you should be unmuted now. If not, if one of the other presenters could unmute him, one of the other facilitators, and then if you want to bring up and share your screen, I would love to start introducing you.
I'm not sure if I can share my screen yet, Bernie.
Oh no!
Screen sharing.
Yeah, I can't find my Meetup program. Oh, here it is. No, that's Zoom. Wait, hold on. Yeah, Bernie, can you like make me not a co-host? I
I'm
can't
gonna
find the-
phone a friend, John.
Okay.
I'm phoning Mr. John. How do I
I think I just stopped his video. Maybe not.
Ah, there we go. Okay.
all right, Mike, can you try again?
Trying. No, still no luck. Host disabled participant screen sharing.
That doesn't sound good.
Oh, got it now.
Awesome. Sorry about that.
No worries.
So go ahead and full screen your presentation, and then, so Mike, you are a research scientist here in Ohio, and you are aware of different monitoring efforts that have been put in place during the COVID-19 pandemic. And I know one thing we were really excited about when you pitched your presentation, well, I had no idea this was happening, but there's a monitoring program going on right now in wastewater treatment facilities. And so you're going to discuss and talk to us about Mix VR, which is a work in progress R package designed to address the challenges of detecting and identifying multiple viral variants from a single high throughput genomic DNA sequencing sample.
You got it. Thanks, Bernie.
Awesome. Take it away, Mike.
Very good. Thanks for having me back again this year. And it's tough to follow Alec and Harry Potter, but I'll do my best here. So yeah, I'm going to talk about this R package that I've been working on putting together a little bit. And but I do want to say that this package is really a very small part of a much bigger project that's happening, and much of that I have nothing to do with. So I'm going to talk about some of that project just to give some context to the package. But before I do, I just want to highlight several folks who I've interacted with, but who are really driving a lot of that work that I'm going to talk about, and especially Seth Faith, who I've worked very closely with. He's with OSU's Infectious Disease Institute Applied Microbiology Services Lab, and there are lots more people than this that are involved in this bigger picture project. Many of whom I haven't even met, but what that project is, kind of like Bernie suggested, is it deals with COVID-19 variants, and my guess is that probably everybody here has at least heard of this idea of COVID-19 variants. I just pulled a few headlines here. There's the B1617 in South Africa, and UK variant and Delta variant. There's lots of them out there. So what are these variants? They're basically slightly different versions of the SARS-CoV-2 virus that causes COVID-19. And those differences are ultimately in the genetic code of the virus, and they come from mutation, which is a process that's always happening. And I think a reasonable analogy here is to think about breeds of dog. And so I just pulled out 3, and you can imagine pulling out the genetic code from each of those dogs and reading it, and just a small section of it here. This is just a hypothetical section I made up, but it looks pretty similar for the most part. But I'll draw attention to 2 spots. Here we've got on the left, we've got an A in the poodle where the other 2 have a C, and over on the right, the golden retriever has a G where the other 2 have a T. And you can kind of think about those 2 positions, maybe the A as conferring some poodle specific trait to that breed, and the G here conferring some retriever specific trait. And it works this way in not just dogs, but any organism, and including viruses. And so down here on the bottom left, I've got our 3, we could think about these as our 3 SARS-CoV-2 variants. So in the context of COVID-19, why do these variants matter? The reality is this mutation process is happening all the time. The reality is most of them don't probably matter to us, but there are cases where they could confer some trait to the virus that would matter to us. Maybe it causes more severe disease. It could cause help that virus spread more quickly or easily. It could help the virus get around some kind of immune response that's developed. And so it's for some of those types of reasons that a lot of groups have gotten interested in trying to monitor and keep tabs on what variants are out there. And the way that works is that if you get sick, you're probably going to go get tested, and it's probably going to be a PCR test. A lot of us have heard about the PCR test now. So PCR is really good at telling you kind of yes or no, do you have COVID or not? But it's not really good. It's not really well suited for kind of the next step is if you have COVID, if you want to know what variant you might have, PCR isn't really suited to do that. But so what you do is you take that sample and you'd go into a next step, which is called which we typically do whole genome sequencing, and that's where we're going to read the entire set of the entire set of instructions, that entire genetic code of the virus, look for any of the mutations that are in there, and based on those mutations, then kind of put it into a bin in terms of what variant it is. The downside to that is that, at least relative to PCR, genome sequencing is rather expensive. It's time consuming, and it's just not practical to do that for every COVID positive sample. And so then, of course, that leaves the possibility that there are variants that we're not sampling that we might be otherwise interested in knowing that they're there. And so for that reason, a lot of groups have kind of gotten interested in thinking about how to do this in a more efficient way, this monitoring. And so the state of Ohio is one of those groups, and they've moved into a program, kind of adopted a program. It's something of an experimental program where they're trying to do this monitoring from wastewater at wastewater treatment plants. And so the idea would be you take a sample from a wastewater treatment plant, you pull out the viral material that's in there, and you do whole genome sequencing on that. And I've just got one example here over on the right. This is called the SatRday plant. It's one wastewater treatment plant in the state. And according to their website, that plant serves over 500,000 residents. And so you can think about taking a sample from that plant, and in that one sample, you're kind of getting something of a snapshot of a lot of the variants that are circulating in that community, and that would be the hope. So one of the challenges that's come up in that process is that when you sample, when you do this whole genome sequencing and monitoring from individual patients, they typically are only going to have one variant. They're going to be infected with a single variant. And that's different from sampling from wastewater, where we fully would expect, it wouldn't be surprising to see more than one variant in that sample, and possibly many different variants and at different frequencies. And the issue with that is that there is some software out there that takes that whole genome sequence and assigns it to COVID variants. But it's really, it kind of makes an assumption that there's only one variant in there. It's kind of assuming that it's coming from patient samples. It's designed around patient samples. And it turns out that when you give it a mixture, it doesn't behave very well. The software, they're both commercial and open source software, but they just don't seem to perform very well with these mixture samples. And so I kind of got involved this past spring in thinking about how to deal with this issue. And so I've been putting together this R package, I'm calling Mixver or something along those lines. That I want to stress it's very much in development, but the idea is to try to use it to explore genomic variation in mixed samples. It can take samples from across multiple locations within a given location, also multiple time points. It has kind of different methods for dealing with kind of different types of mutations, SNPs and indels. If that doesn't mean anything to you, it's not that important. Just different types of mutations that can happen. And it characterizes variation at the amino acid level. I haven't talked about amino acids yet. I will on the next slide. But in the big picture, it basically looks at the mutations in the sample, tries to identify the variants that are in that sample, and also estimate, at least get a rough estimate of relative proportions of those variants that are in there. So before I talk in a little bit more detail about what it does, I have to deal with one thing here, a little bit of basic biology. So I've talked about the genetic code, and that I'm kind of referring to what's over here on the left-hand side of the screen. It's basically nucleic acids. It's DNA and RNA, and those are made up of 4 subunits. We often represent them with A, T, G, and C, but they're just, that genetic code is just a string of A's, T's, G's, and C's, and it's the sequence of those that kind of defines the code for an organism. But it is just that, it's a code, and what it codes for is protein. Protein are kind of those actual traits that you might have. or confer those traits. And proteins are also strings of subunits, but in the case of proteins, the subunits are amino acids, and there are 20 of them to choose from. And so what we're doing is we're using 4 subunits over here in the genetic code to define the sequence of 20 subunits in the protein. And so the way that works is if you take a little piece of DNA in this case, we read it in groups of, it gets read in groups of 3. So the ATG codes for the amino acid M and CAC for the amino acid H, and now we can account for all 20 amino acids. And so the reason that matters for this talk is that when we do monitoring in terms of whole genome sequencing, that technology is really good at giving us the underlying code. But in terms of code variants, they tend to be defined by amino acids. And so we get the data that's here on top, we need to translate it into the data that's on the bottom. And so, so now with that, we can talk a little bit more about what the package does. Every variant, they'll talk about the inputs. There are basically 2 to the program. And so every variant is defined with respect to a reference. And for SARS-CoV-2, for COVID, that reference is there's one reference that's very widely accepted. It was just a virus that was sequenced very early on in the pandemic, and it's freely available. You can go online and download it. And so basically, I have a function create ref that basically takes some of those standard format files that you download in terms of a genome, and it turns it into this data frame where we've got the genetic code for SARS-CoV-2 is about 30,000 ACE, T's, G's, and C's long. And so what I'm looking at here is this is the position, this first column, just positions 23,396 through 23,410, and the base here, the ref base is the base in the reference. And there's some other information here. I won't go too far into the weeds with this, but we've also got the translated amino acid that would correspond to those positions here in a column. And so we need that reference information. Then we also need some information on the mutations in the sample that we're interested in. And so that's another data frame. This actually comes out of other software outside of R to call these mutations, but we have a column here. All of these would be the mutations. And then we basically have information on the frequency of those mutations in the sample. And so I'm just kind of draw attention to one here, where this one is for everything that was every read that was sampled, they were all a G in this case, and that's different from the reference, which is an A at this position. So now what we're going to do is take those 2 inputs, the reference and the mutations from the sample that we're interested in, and we're going to basically merge them together to create what I'm just going to call a sample genome. So we're just taking the mutations that show up in that sample and kind of plugging them in over top of what's there in the reference. And then we're going to translate those into the amino acids. And this actually is done with an R package called biostrings. It's part of Bioconductor. So there's functionality to do this. And because we've got mixed samples, we can have theoretically multiple mutations at a given site. And so we just iterate over as many times as we need to account for all the different mutations at any one site. And then we take the amino acids that are in the sample and compare them back to the reference to look for ones that have changed, because those are what are really important in terms of defining variants. And then we do that process over all iterate that process over all the samples. And as we do, we create this, this larger data frame that keeps track of all those differences that we observe across all the samples. And so the way we define those is basically up here, we've got within a given gene, and a gene is just a portion of that genetic code that codes for a certain protein. Is kind of a block of that code. So here's the S gene at position 759, that's amino acid position 759 of that gene. There's a change in this sample from the amino acid F to the amino acid L, and that shows up in about 24% of the reads in this sample. And so we create this kind of large data frame with all those mutations. And then we take those mutations and we can compare them back to essentially a database that stores mutations that characterize each individual lineage. And so, you know, B16172 here is the Delta variant. There's a list of amino acid changes that characterize that variant. So we're basically just essentially merging joining the alt IDs with those amino acids, or the mutations that we see in the sample with the mutations that characterize the lineages. And so I've been trying to play around here recently with a Shiny app that helps visualize some of these things. And so right now it's got a couple of tabs. It's got a variant identification tab and a mutations tab. So we'll look at this variant identification tab first. In this tab, we choose a site. I'm just calling it wastewater site 1 here. And then we've got a series of variants that we can choose from to kind of that we might be interested in. And so here I'm choosing for this site B117, which I think is the UK, also known as the UK variant, and 6172, which is the Delta variant. And what we've got time along the x-axis here. So these are different sampling times at this location. And so early in, we've got, let's see, the early samples are in April, it looks like. So this first sample in April, what's being plotted there is of that set of characteristic mutations for B117. Sorry, B117 is kind of this pinkish salmon color. For the characteristic mutations, say there are 20 for B117 that define that variant. We're plotting the proportion of those that show up in the sample. And so what this is suggesting is that a large proportion of those characteristic mutations for B117 are showing up at some frequency. It could be 1%, it could be 100%. It doesn't matter, it's just kind of, are they there or not? So we see that fairly strong evidence for that variant through sample points in April, and then it kind of drops off, and then the Delta variant is showing up out here in blue in August. And so we can kind of get some idea of what's there with this type of approach. And then when we say, okay, B117, the UK variant looks like it was there in this first, in April, we can take each of those points and look at the frequencies of each of those mutations in the sample and try to maybe average over those frequencies to try to estimate relative proportions of that variant in the sample. And so in this case, these data suggest that UK variant was kind of increasing over time in that sample in terms of this proportion based on generally weekly sampling through April. And then when we get out here and first sample Delta, it's just kind of at a nearly 100% frequency in the sample and continues there. This is just one more site called wastewater site 3 here, and I've added one more variant to take a look at, B1526. And the point here is that in this second sampling point in April, now we see this idea of a mixture where we've got pretty strong evidence that both the B117 and the B1526, which is in green here, are present. And if we look at the relative proportions that we're estimating, it looks like that B1526 is at about a quarter of the sample, makes up about a quarter of the sample, while the B117 is maybe about 2/3 of that sample. And then the only other thing that I've got is this one other tab. It's View Mutations tab. And this is actually something that I've added pretty recently. This was something Seth Faith had recommended. And so what we looked at before is kind of things that have already been well characterized, and kind of we know what amino acids differences to expect for a given variant. There's also this idea that we want to maybe keep tabs on what new things are popping up that we haven't really characterized yet, new mutations, because that process is always happening, that mutational process. And so this basically just allows us to choose one site, one time point, one given sampling event, and list all of the mutations, kind of browse the mutations that occur in that sample, whether they've been characterized or not. So here we've got one mutation in the ORF3A gene. It's a change from the amino acid S to L at position at amino acid 26 of that gene. In the sample, it's at 100% frequency. And that particular mutation has been defined and characterized in both the Delta and the Kappa lineages, at least based on the database that we're using for this. Then we've got another mutation right below it where we've got a change at position 116 of the ORF7A gene from amino acid L to an F, also at 100% frequency in the sample, but that particular mutation has not been characterized. with any given lineage. And so that might be something that somebody would want to say, okay, we want to take a look at what the effects of that mutation might be. Is that something we want to put on the radar in terms of, is it going to have any relevance to something like public health? And again, many of them won't, but there's certainly the possibility that they could. And so the idea with this is just to kind of give us one opportunity, one way of looking at those novel things that are popping up, new mutations that might be relevant from some type of public health standpoint. And I believe that's all I've got. I'm happy to take questions and more than happy to take any suggestions or advice as we continue to try to put this thing together.
Oh my gosh, I have no advice for you, Mike. I'm just glad that you're working on it. How about that? That was really awesome. I know we've got one question in the chat, so everybody be thinking of questions. And Mike, I also want to thank you for coming back a second year in a row. So you are also 2 for 2 this year with really impactful work. The question that I had put in the chat was, as you were designing this package, what did you have guiding principles that were top of mind for you, or like a specific process that you had as you were thinking about how you actually like build the package, like what kind of interfaces you had and things like that?
Yeah, it's kind of evolved as we've gone, to be honest with you. Initially, this was really just designed for us, kind of internally. This was very much an experimental program, I think. And so we're starting to think a little bit more now, and I have more recently about, maybe down the road, making this more widely available for people to go on and look at different things, and whether that's in the state or maybe there are other programs at Ohio State developing other ways to monitor mixed samples right now. And so so moving into kind of the shiny stuff where it's a little bit easier for somebody outside of us to go on and browse and see what kind of variants are out there. But it's just been kind of putting it together as we go. I don't know if I've had any real guiding principles. I mean, to be honest with you, this is my first go around at really putting together a package on my own. And so I'm doing a lot of Googling around and just trying to learn how to do that, which has been fun. And it's been really good for me to start learning that process. I've been a part of a couple packages in the past, but I've never been the one doing the hands-on writing of the package. So this has been a nice experience for me to just kind of start to learn that a little bit. So,
are you open to PRs on your? I was checking out. You have a great GitHub repo for this. I see you've been working on this for a while now. Are you looking for collaborators?
I think I'm always open to a collaborator out there. Yeah, of course. Somebody feel free to shoot me an email or yeah, you can check out the GitHub site. I'm reasonably okay with GitHub, but I'm not great with GitHub yet. Again, that's something I'm learning more and more. So yeah, absolutely. Let me know if you think you can help. If you've got ideas or want to contribute, shoot me an email. I'm more than happy to chat. Or jump on my GitHub.
The chat is now blowing up. So here is a question. How frequently were the samples measured? And does this contribute to measurement of the tempo of mutations in the communities?
Okay, good question. So how frequently are samples measured? I think that again, this is part of the project that's outside of my realm, but typically I think the aim is they've been sampling every week at I think I counted over 50 sites around Ohio wastewater treatment plants that have been sampled as part of this. And a lot of them are on a weekly basis. Some of them are just kind of one-offs. And again, a lot of this is still kind of experimental. It's trying to learn how we can use this if this is an effective tool. And so there's not so I guess there are a few sites that have been consistently sampled on a weekly basis now for probably at least going back to April, because I know I have data back as far as April of this year. And again, some of them have just been kind of one-offs at sites just to maybe, especially early on, just to try to see, can we even get, I mean, there were questions about, can you even get these sequence data from a wastewater sample? I mean, that genetic code is, in the case of these viruses, actually RNA, which is a little different. RNA is not as durable as DNA, and so it gets kind of beat up. And so there's been a lot of work that, again, I can't take any responsibility for, any credit for, but a lot of work from different labs at OSU, different universities around Ohio have been involved in this, different groups, trying to figure out how to get this to work. Just to get the data in the first place was a big step. I think Battelle was involved, US EPA was involved, Ohio Department of Health was involved. So there's been a lot of groups involved in this.
We've got time for one more question. And then Mike, a bunch of questions came up in the chat here in the last couple of minutes. So maybe during the break or afterwards. Awesome. Was there any sensitive data involved in this project? If so, and I would even say, if not, let's have there was sensitive data. How would you handle that as an R developer building a package? What are some of the things you would be thinking about?
Yeah, that's a really good question. The simple answer to that in this specific project is no. There's not any sensitive data that I'm aware of, because what you're doing is you're nothing's tied to an individual. I mean, I guess you could tie it back to a community of 500,000 people, maybe a variant, but that's the best you could do. So I don't think there's any real concerns about personal genetic data or genomic data coming out. Now, you would have that issue if you were doing, well, actually, no. So beyond that, even if you're doing patient samples and you have an individual patient sample, what we're doing is we're selecting the viral material from this. So you're not actually getting any information about that individual's genome, genetic material. It's the genetic material for just of the virus, where we're specifically amplifying and targeting the viral material. And so now, I actually am not a good person to answer the question of how you deal with sensitive data when you do have that. So when you're dealing with individuals' genetic data, and there are probably people on this meeting that have a lot of experience in that. I actually right now work in plant sciences. I've got most of my experiences working outside of the human world, frankly, and so I've never had to deal with that a great deal, and I'm kind of glad, because I know there's a lot of effort that you have to take to make sure that that sensitive data is protected. So unfortunately, I'm not a good person to answer that question of what advice I could give, but I know there are people on here that can, that probably have thought about that a lot.
Well, thank you for sharing your time with us, Mike. This was awesome. Take a look at the chat questions. I did a terrible job facilitating Q&A now, so there's a ton of stuff in there. We're gonna go on break now, up until 11 a.m. Eastern. So at 11 a.m. Eastern is actually when the next session will be beginning. Ezgi will be introducing our speaker at that time. And so this Zoom meeting will remain up during this time. And I believe Trevin or Ezgi will be posting the schedule here, the break slide, as we call it. I've had a wonderful time talking with Alec and Mike this morning, and I love seeing everybody here in the meeting. So thank you all for attending, and we'll be back at 11.
Well, hello everyone. It was such a great first session. George, let's try to put your screen up at least while we're waiting still for the people to trickle in and the break to be over. Perfect. Okay, I think we can get going. It's my pleasure to introduce George, and he's also a repeat speaker, so he also gave a wonderful talk last year, and happy to have him again. And he has his own consulting firm where he also provides training, and we'll be hearing about the power of BI from him today. Oh, of course, I should also add that we have the whole raffle on his book. So his book just came out, and I think it's supposed to be a really great book to help transition people from the typical Excel world into the data analytics using more programming.
That was a good pitch. Thank you. Okay, let's start this up here. Great morning so far. Hope I'll continue it here. So what I'm hoping to do today is have a good conversation on where Power BI fits inside of R, give you a couple of use cases. I want to make this as conversational as possible. You know, there's only so much demoing I can do in 15 minutes. So I think, you know, having a good conversation might be a better use of time. Okay, so first out of the way, I should have used this title. I wanted to keep my title in keeping with my title from last year, and I have a resource link to that in the repo. I'll also share the link out to where to get the repo in a minute here, because I've got some goodies for you. Because you always have to keep with the R. Yeah, we've got a brand to maintain, so I had to do that. Anyway, let me. That was not what I wanted. Okay, what I wanted to do was give you the link to the repo. So let me put that in the chat, make sure everybody has that. And why am I struggling so much here? Okay, how do I get to the chat from? Oh, I have my little pane here. Okay, there's that. There's the repo. And I think I'll probably just keep my slides here so I don't have to fumble through so many different windows. But what I want to do, like I said, here are the presentations. Here's the repo. I've got all the scripts used in the file available, and then there's a completed file in Power BI for you to look at. Okay, I've never done this before. I wanted to try this out. You know, I was hoping for there to be some Power BI users here, some R Shiny users here. You know, maybe there is. So I have a file here, and that's going to open you up to a Google Sheet. Now, if you want to, in the minute or two, if anybody's got ideas on when they use Power BI with R, for what use cases, if you're thinking about using, obviously, I mean, Shiny is kind of the obvious elephant in the room when we're talking about Power BI and Shiny. What to compare, contrast, we're all living in the real world. So there are certain real implications of using one or the other when you're in a setting. So if anybody's got thoughts, questions, I'll just kind of seed it over to the spreadsheet. We'll see how this goes. And if there's no takers, then I'll power through, no pun intended. But I'll stop speaking and let it.
Yeah. So do we have access to the sheet? So maybe if we can actually have a link, we can.
That would be good. Yeah, I put that in the. Always good to make sure people can get there. I put that in the slides, but I didn't think about sharing it again. Okay, so there's the sheet. I think people should be able to get in and edit. So just put your thoughts, and we'll see how this goes. Oh, I see a raised hand. Craig, you can ask me here in the chat. Thanks everybody for sharing your thoughts here, because I'm always interested in hearing how people approach this topic themselves. And this isn't as nice as like a Miro board or something like that, but that's kind of hard to set up, even when you're all in the same organization. So I figured this would be a little easier approach. So let me know how it's working. Oh yes, I hear something from Craig, I believe.
Sorry, I'm driving, and I just wanted to ask if you can do multiple sheets like in Shiny in Power BI. That's my question.
Multiple sheets, like multiple pages of a report. I think you could do that if I'm getting the question right. Maybe when there's a red light, Craig, you can follow up. Okay, I think in the interest of time, I'm gonna keep going. But if you want to update this as we move on, that's great. So I'm seeing that there's some people are using it, some people aren't. Okay, graphics, we're definitely going to get into that. Yeah, the technical, the learning curve is a factor. The other thing that I think comes up is the deployment, right? I mean, if you're in a Microsoft infrastructure, it's pretty easy to push out a Power BI report versus going into Shiny. Okay, questions about advantages of Power BI. So I'll get into that. Power BI and Tableau, that's a landmine there. When Power BI doesn't have a native connector, well, maybe one of the things that we'll go over might help with that. So I really appreciate everybody sharing their thoughts. Like I said, having a little conversation here is a great use of 15 minutes, I think. Okay, so I'm going to keep going. Here's what I see as the use cases. Now, one of the things that I'll recommend is, if you're not familiar with Power BI, probably should have had a slide on that. The idea is that it is as the name implies, a business intelligence reporting tool. I think of it as kind of the next generation of SSRS, SQL Server reporting. It has some tools for ETL. It has tools for relational data setup and modeling. And we'll see a little bit of that in the next few minutes, although I'm certainly not going to get into everything that I have in my demo, although I will have the notes so you can check that out later. But one of the things that I would suggest is to not use it gratuitously. With R, there are some ways to use R. It's a little hacky, you'll see, but there are some use cases where it really is meant to supplant what can be done in Power BI. There's a reason that there are ways to use R and Python, for that matter, with Power BI. I think it's really interesting that Microsoft has outright admitted that, right? Because historically there is a lot of bad blood between Microsoft and open source, but that's not necessarily the case anymore. And I think that this thing is a good example. So some of the things that would be great for you to use, if you have things that are coming from an API, for example, you can insert an R script. We're going to show you how to read in a CSV file with an R script. It's kind of a gratuitous use of R, but just in the time that we have. And then any kind of more advanced statistical modeling, machine learning, that is something that Power BI just doesn't support. So I think that is a prime use case. If you've got missing values in your data set, if you need to do some kind of principal components, or all the use cases, I don't have to list all of them. That's one thing that R can certainly help with. And then anything that you're dealing with, I think when you're getting into text, unstructured data, things like that, Power BI is really meant to be a relational data model. So if you're taking more unstructured kind of data and trying to fit it into a model like that, that's another great use case. And then the obvious other one is visualizations. I remember speaking with someone at our cafe a couple of weeks ago. I believe Raj, was that Raj's name? Did I get that right? Whoever that was mentioned that, sometimes there are spots where the graphics in Power BI just don't quite cut it. If you have some very specific use case, ggplot is so infinitely moldable that you can really make whatever kind of graphic that you need, and you just don't necessarily have Jairaj. Okay, so I was half right. You don't necessarily have the support to do that in Power BI. Okay, so only got 5 minutes. I don't know how much of the demo we'll get to. But one of the other things, if you're looking to get this set up, it is free. You have to be on Windows. You can do any work and any development in your local Power BI desktop session. However, to actually publish that and deploy it for other people to check out, you do need a paid account. The licensing of Power BI is not something that I want to get into, because does anybody understand it? And then the other thing, once you actually get that set up, there is a little thing you need to do to actually hook up your R to Power BI. You'll just go into your options and settings and then check the R script there. Okay, so the demo that I have, and we'll see how much I get into it here, is I've got 2 data sets. The idea here is that there was some kind of intervention, and we want to see how the scores of the participants change before and after that intervention. So pretty simple, 2 data sets. We'll bring it in. I'll show you how to import data from R. Then I'll do just some a basic regular expression thing. I don't know how useful it is to try to identify email addresses, but just for the sake of example, show you that you can work with regular expressions and text with R, and then we'll make a custom plot. But like I said, I probably won't get to all of it. We've got the demo notes for you to check out. So what I'm going to do, if there are any questions, let's look for those first, and then I'll hop over to Power BI. Just going to start with a totally blank report here. And there are a lot of data sources that you can bring in, not everything. New connectors are being introduced all the time, but we're going to start with just very simple tabular data. So, the one thing that you'll do, and I might just show the script here for this, and then I'll go to the conclusion and take questions. But I'll walk through everything. Maybe I'll open up the final report and we can go from there. Okay, so you can open a tabular file, easy enough. What you're going to see is that there is an ETL tool that shows up. This is called Power Query. If you were to go in here, you could do some data cleanup and things like that. I'm going to load that in. The other thing that you can do, and you don't really need to do this, but I'll show you anyway, and then we'll go to the slides here. So I brought that in. We see it over here. This is a relational data modeler, right? So what I'm going to do right now is bring in another data set, and I am going to bring in this from an R script. So I'll go to more. There are going to be a lot of options here if it loads. Okay, so I'm going to look for R script, and there's that. Okay, so I'm just going to copy and paste this, but anything that you do, this R script should be kind of self-supporting, right? So any packages that you need, this is going to call in from whatever you have pointed to on your computer where your R is installed. So I'm going to bring this in. I'll read a CSV file. And then you need to specify the data frame name. I'm going to load that in. And you'll have the same options. So once you do this, you could use the ETL tools with Power Query. I won't do that for the sake of time. I will load this in. And then what you'll see is that once it loads, automatically relationship is detected. So there's a lot of DBA kind of work that goes on in Power BI if you start learning it, but it does have some basic intelligence. Okay, so I'm going to go back to the slides here. Let me show you the final product, I guess, just so you get a sense of what it is. If that loads. Probably hear my computer fan. And I might, okay, there we go. Yes, so there is some privacy security kind of things you have to waive off, which is fine. So the idea here is that, and this isn't a great example of a dashboard, but just to give you a sense of what you could do. So I put some data here. I added a slope plot, and you could even, the nice thing too is that depending on the way you build this, you could set up a table that has the data, and your Power BI is going to readjust your plot, right? So as I'm clicking on these groups, the ggplot influenced chart changes. So there is some cool interactivity. I mean, this is obviously a lot easier to set up and deploy than something like Shiny. And it's a little hacky, if you follow the demo. It's not great to do sometimes, but it does things that Power BI natively can't. Okay, so yeah, there are a couple of books that are out on this. This one out now. This one's coming out any day now. If you want to check out my Excel version of this talk, you can go to that. And then obviously, as was mentioned, I have the book. So if you win it, that's great. If you don't, I will put a link in the chat. You can check it out. O'Reilly lets anybody read for free with a 30-day trial. So you can check it out. And I would say that everybody's a winner in that case, since you can get it for free. Okay, so I'm going to stop my sharing. And if there are any questions, hope that gave you a nice overview. Like I thought, there would be people coming from a lot of different angles on the topic. So I hope that it was a nice primer for you. Cool.
I guess I will start with the first question on my side.
Yeah.
So do you typically use this workflow on a day-to-day basis?
I do it sometimes. It's not very often, but the Power BI adoption is really accelerating. So it's something that I'm asked to do and asked about more and more often. And I think that the idea that Power BI was built without really any supported version control or change tracking, that's pretty hard to swallow. But so having something like R kind of helping under the hood a bit with that, I find very, very supportive. But yeah, it is definitely, I think I saw something like 98% of Fortune 500 companies are using Power BI or something like that. So it's a pretty common tool out there.
Yeah, I have no doubt. And I mean, it's definitely needed, especially when you just don't have time to train people up, upskill, and it's just such an easier user interface to just interact with. So I guess other question would be, can you share those dashboards with other people? How easy it is to share like a BI?
Yeah, so you can publish them locally and share them with people in your organizations. If you were to try to share outside of your organization, there are some ways to do that. I mean, you're going to end up with a binary file for the report, so that's easy enough to share around. Some of the whole pipeline, like your data sources, and that can get a little messed up once you start sharing that end point file. But yeah, it's pretty easy to get up and running, especially if you're in Microsoft Shop. I think it's like $10 a month or something for a user license. As far as setting up the server and deploying that gets pretty complicated. But yeah, for an end user, it's not too bad to get up and running.
Yeah, and then we have another question actually in the chat. Is the thought that BI analysts would learn a little R to do these tasks, for anything that's related to R, or would there be a handoff typically?
That's a good thought. I mean, you could maybe think of Power BI as like a prototyping tool if you wanted to move it into Shiny, and I'm sure people are doing that. The way I'm approaching this is that, yeah, if you're a data analyst and there are just some things that for whatever reason Power BI can't handle, you need a chart done in a certain way, you need to handle there's some missing values, there's some influential cases or something like that in your data that you can just insert that and not be gratuitous about it, use it strategically. But there is a reason that R, and then really anything that we're doing in R could be also done in Python today in there. So.
Yeah, and I mean, there's another question, but I think we kind of covered that. Obviously, within this R community, we'll keep asking the same question, right? What is the advantages of the Power BI aside from the simplicity compared to Shiny?
Yeah, I think, again, repeat everything that generally you're going to have less of a headache trying to deploy a Power BI report versus something like Shiny. The server's already there, the infrastructure's there, and then you publish it, and the ease of use is definitely another consideration. But as far as reproducibility, anything like that, it's a problem. Even people who aren't usually too concerned about version control get concerned about it with Power BI.
Yeah, exactly. And I mean, I think that's one of the beauty of Shiny as well. I mean, once you have a framework more or less in place, you can kind of apply that to different use cases potentially. Does Power BI have any option like that at all? Or like, can you just create a template Power BI and move on to apply that to different scenarios somehow?
Yeah, I think there is a way to do that if anybody has experience in that, but I know that generally you're not starting from scratch when you're building a Power BI report. As far as the question on deploying Shiny app as a package, if anybody has thoughts on that, that's not something that I am too familiar with, but thanks for all the questions. It's cool to have the conversation here. Yeah, advanced editor, that's true. Yeah, so I should have mentioned that too, that the Power Query ETL tool is a reproducible tool, right? You're using a GUI, but if you wanted to under the hood, you could manipulate the code that goes on under there. There's also another language that you can use for adding measures and things like that to your relational data model. So there are some code-based tools. However, the Power BI file is just a binary object. And, if you were to make a chart in there, it's not necessarily, you can't export any kind of code to show how you built that chart. So, some things are more reproducible than others, I would say, with Power BI, but it really is pretty easy to get up and use and then get up and running.
Yeah, thank you so much.
Cool. Yeah, thanks everybody.
It was so great seeing you here again.
Thanks again, and good luck on winning the book. But I put the link if anybody wants to check it out. You can read it on the publisher site. So cool. All right.
Awesome. Thank you.
Stop here. Oh.
Okay, I think Shane. Let's see if we can share your screen.
We good?
Yep, I see it.
Cool.
Definitely. Awesome.
All right. Awesome.
Well, Shane is joining us from not far from Columbus. He's in New Albany, and we'll be talking about how to get started with art, which I'm really close to my heart. So I'm very excited to hear his talk today.
Cool. Well, yeah, thanks for having me today. This is gonna be a little bit different subject, and hopefully looking to speak to those of you who are here today with maybe not a whole lot of background, or maybe this is one of your first introductions to R. I probably still consider myself in that group, honestly. Up until about a year ago, I hadn't been using it at all. And up until about a year and a half ago, I hadn't even heard of it. And I'll go a little bit about my background, just to kind of maybe give some inspiration for those of you first starting out, because it can be really daunting. So yeah, I'll open up Q&A at the end, but I'm just going to run through some stuff here and kind of a brain dump of what my path has looked like so far. So I started out, graduated at Ohio State in 2016 with a business degree. I don't know that I use any of that now in my day-to-day, but it was cool to have something. Went into auto body after that. Won't go into a lot of detail. It just happened to be the right opportunity came up. After that, I wanted to actually do something with my degree. So I was working for an agency doing more like strategic level stuff, kind of advising small businesses on really basic digital marketing, just to give them something to work with. They usually didn't have like a marketing department, anything like that. But as I was doing that, I was in kind of an account manager role, and I realized that I identified a lot more with our special operations teams. So like our web developers, our digital advertising department. I liked what they were doing a lot more, but I didn't necessarily want to do it there. So I ended up leaving that agency and actually took over digital advertising for another agency as their digital advertising manager. And I started to really get into that realm a lot more. I liked working with numbers a lot more. I liked working with data and different tools. And that was when I really started to realize where I wanted to take things. So I was a couple of years out of college and kind of started to get an idea of what I wanted to do. And it kind of started just Googling, like, what can I do with a marketing degree? I figured I've already got something built up here. Where can I go with this? I knew I like data analysis. So I started kind of fishing around for what was out there, what people actually do. And I think like, probably 80% of us, I heard about what a data scientist is for the first time and sort of naively thought, oh, that's what I'm going to do. And that remains to be seen. I don't know that that's necessarily in the future, but as Tim Wilson puts it, being an analyst, doing some data sciencey stuff. So it's about that time I started, researching what I really need to learn to get into this, and that was how I found R. Started using it, for where I could with what I was doing work-wise, but there just wasn't a whole lot of application for it. And I really liked the company I worked for, but where I saw myself going, there just wasn't much of a fit there. So I did do some like BI stuff while I was there. They were super generous and flexible about letting me sort of explore options. And that was when I first started exploring more tools outside of like Excel or the UIs that come along with some of the MarTech tools. And Power BI was actually my first endeavor into something that was a little bit slightly more advanced for someone who'd never done anything like that. And then I found R. So I'll talk about kind of how that introduction to R happened and some resources that got me to a workable spot with it. So I'll put the caveat here. These are just my personal tips. Everyone's going to vary a little bit, and I'm sure everybody here would be able to offer some insight as to what's been useful for them. So take this with a grain of salt. This is just kind of my take on it. First off, I know it's easier said than done. Try not to be intimidated by it. If you've never seen a programming language like I hadn't, it looks really daunting. I actually started out trying to learn Python, and that went nowhere. But I decided I want to try like an online course, and that online course used R, and for whatever reason, it just clicked a lot more. And it's a lot to take on at once, but if you take small bites out of it and just work on even just starting to learn dplyr or something and some base R, that helps to bring the intimidation factor down a little, which kind of leads into the debugging process. You're going to get bugs and your code's going to fall on its face, and that's normal. My code always fails now. I don't think I ever get anything on the first shot unless it's a really basic like filter, group by summarize kind of thing. So don't be discouraged by that. It's going to break, and you're going to spend a lot of time on Google and Stack Overflow, but that's okay. Next, quick bit here. This is actually a quote from a buddy of mine that I played music with. He told me one time at a jam session, he said, always play music with people who are better than you, which is useful for getting better at playing guitar. And it's pretty good for data analysis too. If you can plug into the right groups and associate yourself with some people that know way more than you do, they're going to be a good resource to learn on or lean on. And I've found that the data community is usually pretty helpful, and we like sharing our thoughts on things and learning new things. So there's usually someone out there to help you along. And then just kind of play around with strategies that work for you. Videos, online books. There's tons of free online books. The projects thing, I want to touch on this real quick. The leading consensus seems to be, start out with R, find a project that interests you, and use that as practice. And I think that probably works for most people. And I've done it a little bit, but honestly, what I found is between learning the stuff and, extra reading and then, with the work week, I found myself honestly just not having a whole lot of time that I wanted to spend on, some sort of project. And there weren't a lot of projects that interested me that much that I was going to use R for. What worked the best for me was actually finding ways to use it in my everyday work that maybe traditionally weren't a task for R. So even if it's something simple, like if I had an Excel file that I was doing something in, if I had an extra, 20 minutes that day, try to replicate it in R. See if I can do the same thing with some basic tabular data. And it gets you quick on, some of the basic operations, especially like with dplyr and some of the tidyverse stuff. Just getting used to what to use and when. Basically replicating stuff that you would do in other tools, but doing it in R, and it gets you a little bit more comfortable with it. So that might be a little different than the typical route people go. If the project route works for you, by all means, go for it. There's a lot of cool, interesting stuff out there, but I ended up using more from work. A couple other tips there, find some examples. I'll talk on the next slide a little bit about some resources for that. When I first started, I had no idea what people even use this for. I was like, oh, I'm supposed to learn R, but why? Seeing what it can actually do and what an output looks like was super helpful for me. So seeing examples of what people actually do with it, why it's useful over another tool, that kind of helped get the wheels turning a little bit. And then the last two kind of go hand in hand. Your code's not going to be perfect. And if you look back on something that you did 6 months ago, it's probably going to look atrocious compared to where you are, at present, or even a year from now. You're going to look back and you go, oh, why did I do that? It's okay if it works, especially if it's not something, super important, at least take that as the W and keep going with it. And to that end, comment your code. I can't say that enough. I've got old scripts I wrote that I pull them up now. I'm like, what was I thinking? I've got no comments in it, so I have no idea what it's trying to do. So now I comment my code to death, and it helps not only me, but if I'm trying to, create a reprex for somebody or, help get some help troubleshooting it, comments help a lot. So don't be afraid to use those. Quick list of some reference materials here, and just starting out, edX, Coursera, Kaggle. I've used all three of those with varying success. And then the books, like you're going to hear people talk about Hadley Wickham's stuff, like R for Data Science. There's a whole Slack group for that. A couple other ones on there. I do want to point out W3 Schools. It's not like directly related to some of this stuff, but it's helpful if you have no programming background, just to understand like how it works, to get an idea of what programming language is compared to working with Excel or something. And then use all the documentation that's available. That's the biggest help for me even now. A couple other lists. I can always shoot these out after the talk too, but just some cool stuff to look at. Again, not super directly related to R, but I do want to point out regex 101. This is used, by like devs that I work with on computer programming and stuff. Really anybody that I know that works with programming. That regex 101 site is awesome. You can test out regular expressions and try to get them to work instead of trying to run code over and over again if you're working with strings a lot in R. So check that out if you're having trouble doing a lot of work with like character stuff. And then this last one, Trevin actually turned me on to this exorcism site. It's like brief little exercises you can do each day. And some of them are like really hard, way harder than I would have imagined, because they are more like programming rather than like data wrangling. So it'll get your brain working. We are at time here. If there's any quick questions, I'm happy to go through them. If not, I will turn it over to some other folks here.
Well, thank you so much. I actually have a quick question, just curious. So for example, you mentioned R4 Data Science book, which is an online book. It's open to everyone, which is fantastic. And it's written in Bookdown, which is, again, can be written in R. So that's also great. How much of the Slack, which actually accompanies the book, have you used, and how much did you interact with people?
Yeah, I do really want to mention that too. I didn't touch on it a whole lot. So if you're not part of this Slack in general, I suggest joining a couple communities. But I use that R4DS Slack quite a bit. I've actually had like some more complex questions answered in there. One was just this past week. I was trying to do some stuff with like completing missing values that I got a response, and I'm glad I put it in there because it's it was a function I'd never even heard of. I was like, oh yeah, I never would have just figured this out trying to Stack Overflow this thing. So it's super useful. And to that end too, if you're in, like I'm a digital analyst, so I work a lot with like the Google suite of packages and stuff. If you're in that field, I really recommend joining the Measure Slack too. And there's a data science channel in there where most of like the R and Python people hang out. So that's a really good resource as well.
My second question is going to be the meetups. I mean, given that we are currently in the middle of the still situation with COVID, and we're not able to meet in person anymore, and that also slowed down, for example, our ladies, which I was organizing with Katie. But has meetups had any impact during your process, or what meetups would you suggest if we were to be able to come back?
Yeah, so I've only ever done one of them. And it was probably one of the most pivotal things that I've done. It was way early on in this when I was still like running digital advertising. And again, I still kind of had this, I hate to put it this way, but I had this kind of pipe dream like, oh, I'm going to be a data scientist. So I went to the Columbus Data Science meetup, and I met a gentleman there that actually worked in insurance, oddly enough, which is now what I work in. And he was a data scientist for a local insurance carrier. And he was just super helpful. We connected on LinkedIn after that. With pointing me in the right direction, and he was happy to talk. And that kind of really sparked my interest. Like, okay, I'm going to go do this now and try to, learn some of this stuff. And not as much of a meetup, but there are book clubs in the not the Shiny Slack, the R for Data Science Slack too. Scheduling conflicts kind of got me on that. So I'm not doing it right this second, but I did a couple of weeks for the Shiny one. And those are super helpful too. They're relatively unstructured, or at least the one I did, and super helpful people in there, and you just kind of follow along the books, kind of keeps you honest and keeps you accountable.
Yeah, and just to mention, I guess with the book club in that case is kind of going through the R4 Data Science book, kind of chapter by chapter, right? You can join different channels even if you needed to, I guess, and then you're going through the book together, I think.
Yep, and I think it's probably the same for R4DS too, but like I said, I did the one for Mastering Shiny. And that's a whole different world that I'm getting into now. And it's super overwhelming. I'd consider myself relatively comfortable with R now, but Shiny is a whole different world. So it's good to have some resources to lean on there, because that is more into like, web development almost. Like if you've got any computer programming background or web development, it'll probably come a lot easier. But if you're more from like a data analysis background, it's a little daunting. So a group like that's super helpful.
Yeah, I think I just have one last question, and then we can kind of wrap up. But how much of you think your training was mainly open source versus I don't know, MOOCs or additional certificate programs?
I would say now pretty much all open source. Outside of there's more school stuff happening probably in January, but now I'm mostly, all the documentations, Stack Overflow, Google, anything I can find, and all those other things listed here too. Starting off though, yeah, I did a few paid courses. There was one through HarvardX that I found super useful. It's I think it's like Intro to Data Science or something like that, R Basics, yeah. There were a couple on Coursera that I did for ggplot. They were pretty useful, and now I'm actually doing one for Python in Kaggle, and it's not paid. It's free, but yeah, I did start off with a couple paid courses and got those certificates, and they were nice for a first introduction. But I think those who have a little more fortitude than me could probably do the same thing with just open source and not spend a dime.
Yeah, that sounds great. Thank you very much again. I hope this is an encouragement for everyone out there. I think that's always really important, because I know when you first start, it's kind of an uphill battle a little bit, but
100%.
when you can get over it, it is a really lovely scene. It's a really lovely landscape, and there's lot to explore even after that. So thank you so much for your talk.
Absolutely. Thanks for having me. Hopefully it's helpful.
All right, thanks so much, Shane. And I apologize for the various messages and putting you in the waiting room. I'm in a smaller screen now. Having a better tech day than me. This is now my second computer of the day. The other one is still live streaming though, so we'll just let it chug away. Brandon, while I'm sort of setting stuff up, if you want to start making sure you can unmute yourself and share your slides.
Sure.
And while he gets set up, I want to remind everyone, we are going to do the first book raffle after this talk. So right at the beginning of the lunch break, I'll do the raffle. I'll have to awkwardly go back to my other computer where I have my R script where it's streaming this chat still. What I have is an R script. What it does is scrape out the chat, grabs everyone's names, takes out the organizers, and then someone's going to win. So all you have to do to be entered into this raffle is say something in the chat. You can say hi. We prefer if you ask a question, but anything will get you entered. So we'll do one at noon, a reminder, and then we'll also do one at the end of the day. And it's cumulative. So if you talked at any time during the day, you'll be eligible for the evening one as well. All right, Brandon, I don't see your screen. Are you able to?
Sorry about that. Can you guys hear me okay?
I can hear you.
Okay, let me share I had to restart Zoom in order to share my screen.
Don't worry, I can't. I've had way more Zoom problems today, so yeah, I understand.
Right.
Yeah, it is.
Okay, are my slides up? I'm having a hard time telling.
It's your whole screen. So don't open anything sensitive. This is live. So we see like a document. We see your RStudio in the background, but no slides.
Okay, let me see if I can fix that real quick. You can tell I'm not much of a Zoom user.
That's okay.
All right, how about there?
Okay, great. Okay, so let's pause for a second. Bernie, this is where you will cut the video. Okay, we're very lucky to have Brandon Greenwell here today. Tell us about calculating Shapley values to interpret machine learning models. He's a data scientist from Dayton, and he's also the co-author of Hands-on Machine Learning in R. And we're very excited to have him. So Brandon, go ahead and take it away.
All right, thank you. Sorry for the hiccup. Thanks for the opportunity. It's nice to be here to be able to talk about an important package I wrote a couple of years ago, and also be part of this fantastic lineup. So I'm going to talk about a particular area of machine learning interpretability around Shapley values or Shapley explanations, and kind of where this FastShap package kind of fits into that that area. So these slides are available on GitHub. There's a link here. But before I get into that, just a bit of a plug for a couple of other packages and books. John, thanks for calling out Hands-on Machine Learning. So whatever free time I get in terms of research or package development is usually geared towards this area of interpretable machine learning. So a couple of other useful packages if you're a practitioner is there's this PDP package for partial dependence plots or ICE plots if you're familiar with those. And then I also have this package called VIP for variable importance plots. What's really cool about that one is that RStudio actually uses that one for a lot of their machine learning training, and I think they're using it in their upcoming Tidy Modeling with R's book, if I got the name right. So that's pretty cool. Some books. So like John pointed out, I did co-author a book called Hands-on Machine Learning with R. That's also based in Bookdown. It's also freely available if you want to go check that out. That's with my other colleague at 8451, Brad Bemke. And I do have a new book coming out on decision trees, so modern decision tree algorithms and tree-based ensembles. That was actually due last month, but I'm a bit late on delivering that. By the way, this is not the actual title or the book cover. I just got bored one day. I don't think the legal department would let me get away with that. Part of the reason for the delay in that book is my son, who was born in August of 2020. As you can imagine, there hasn't been a whole lot of time for writing, and so it's nice to be able to get out and talk at a conference about some of this stuff. I haven't done this in a while. Okay, so onto the content itself. So again, machine learning interpretability has been around for a long time, but it's started to be recognized as sort of its own emerging sort of niche little subfield of machine learning and predictive modeling. And so things you typically see in a machine learning pipeline that have been around for a while are like things like variable importance, feature effect plots. So those are starting to catch on in open source and proprietary software. So, if you're a machine learning user, whether you use MLR3, scikit-learn on the Python side, you'll see things like permutation importance, partial dependence plots, ice curves, and things like that. These are all fantastic methods that sort of let you, in a model agnostic way, help understand how your features impact your predictive model at a global level. But a lot of times we also care about answering similar questions, but at a more granular level. So for example, which features are important and how do they affect individual predictions? And so you can kind of think of this as sort of like a local or case-wise type of variable importance, but also with magnitude and effect. And we more often refer to these as sort of like prediction explanations, or I prefer to refer to them as feature contributions. And so the idea is I have an individual prediction and I want to understand what features and their values sort of had the biggest impact on that predicted outcome. So there's a lot of different ways to sort of tease out that information. There's a lot of methods and algorithms that are out there. Many of you might be familiar with LIME. I'm not going to pretend like I remember what that acronym stands for. But we're going to focus on probably the currently most popular method, and that's through what we call Shapley explanations or Shapley values. So the idea of a Shapley explanation in the context of predictive modeling is, so say I have some arbitrary observation. This might be an observation in my training set or a new observation. And what the Shapley value provides is how much each of the feature values in X contributed to the difference between its predicted outcome and some overall average baseline value. That might be like the average prediction across a training set or some representative background data set. So the idea is like, what about this feature's values, this X0, contributed the most to this difference? And so the idea is based on Shapley values. Shapley values have been around since the 1950s, I think. I think the 1950s. It's an idea from cooperative game theory. So I'll talk about that here in just a second. And the nice thing is that we can use these to answer sort of that individual, row level type question, sort of what features and their values contribute the most to a particular prediction. But the nice thing about them is they satisfy a number of properties that let us actually aggregate them also into more useful global summaries like variable importance and things like that. So they have a lot of usefulness. And the nice thing about Shapley values compared to other methods like LIME and anchors and other things is that since it's based on this idea from collaborative game theory, it satisfies a lot of useful properties associated with fairness. So we're trying to explain like what feature values contributed the most to this difference up here, but I want to be able to attribute this difference fairly to the individual prediction, the individual feature values. And so what Lloyd Shapley did was, before deriving anything, he wrote out what he thought were these reasonable properties that a fair attribution method should satisfy. And so things like local accuracy, missingness, consistency. Local accuracy simply just means that the individual contributions of all the feature values should add to this difference. So they're inherently standardized, which is a good property. Missingness in the context of predictive modeling. If a feature value doesn't contribute at all to a prediction, it gets a Shapley value of 0. So things that you would think make common sense. And so he wrote down these reasonable properties of fairness and determined, or at least prove that the only feature attribution method that actually satisfies these properties is what's called the Shapley value. And so in cooperative game theory, it's the average marginal contribution of a player across all possible coalitions in a game. It's got this gross looking formula right here. But how does this translate to machine learning? So the idea is that in the context of modeling, the game is a prediction task for some observation X naught. The players are the individual feature values that collaborate to receive some gain or payout. And the payout that I want to evenly and fairly distribute to the individual feature values is the prediction for X minus some average baseline prediction. And so again, the actual theoretical Shapley value is something that's has some difficulties in terms of computing exactly in practice. And so fortunately, there's a number of different ways in which you can approximate Shapley values. The one I'm going to talk about today, and probably the one that's most commonly implemented in several R and Python packages, is due to Strumbelge back in 2014. They showed a relatively straightforward Monte Carlo approach to estimating the Shapley values. And so here's sort of an image from their paper. And I don't think we need to go through and understand the minute details of this algorithm. But at a high level, in order to approximate a single Shapley value, what you end up doing under the hood is you have the instance that you're trying to explain. You need to draw an instance at random from the training set. And then you're going to randomly swap out or trade some values between these two instances. And the values that get swapped out between the instance you're trying to explain and this randomly drawn instance from your training data is dictated by a random permutation that gets generated before that. And so the only thing I want to kind of take away from this is that where sort of the bottleneck is in terms of computing Shapley values. So one of the drawbacks of Shapley values is that unless you're in certain situations like dealing with tree-based methods where there's computation shortcuts, even estimating Shapley values in practice can be very computationally complex. And so for large data sets, a lot of algorithms that provide this it's infeasible. So the idea of FastShap is how can we sort of take this procedure right here, which is basically just based on randomly swapping values between the instance you're trying to explain and some randomly drawn instance, and how can we scale that out a little bit better? And so the idea is, well, first of all, so this algorithm can look kind of complicated, but it translates pretty easily over to simple R code. So here's a very simple, bare bones R function. And yes, I do still use dots in my variable name and function names. I don't want to get any hate mail for that. So here's a very simple translation of that algorithm. And essentially all you're doing is it's just a simple for loop, right? I'm going to take a random instance from my background or training set. I'm going to generate a random order of the feature values. That's my permutation. And then according to that, I'm going to swap some values out between those two instances. And then the Shapley values where I just score those two swapped out instances, and the difference between those predictions is my Shapley estimate for that particular iteration. But herein lies the bottleneck. Anytime you want to do a single run of this algorithm or compute a single Shapley value, it requires two calls to a scoring function, this f of x. And if you're dealing with an expensive scoring function, like a random forest or something like that, calling this several hundred or several thousand times can add up. And this is sort of where one of the bottlenecks is. So this is where FastShap comes in. So in order to run that algorithm to explain all the feature values for a single instance, or if you're doing that for multiple instances, you don't typically just want to explain one prediction. Maybe you want to explain the 30 highest predicted outcomes, or maybe you want to explain a large sample of your training set. At the end of the day, running that algorithm requires 2 times NP calls to whatever your scoring function is. So M here is this is a Monte Carlo algorithm, so you have to run it several times, in this case M times, and then you just average the individual approximations together. N is the number of instances you're trying to explain, and then P is the number of features you have. And so especially with N, I mean, this can blow up really fast. And so what FastShap does is it gets rid of this factor N. So if you're trying to explain hundreds or thousands of instances, or if you're just trying to explain a single instance 100 or 1,000 times, what FastShap does is it says, okay, if all I need to do anytime I compute a Shapley value is generate a random permutation, and according to that, swap some values out between the record I'm trying to explain and some randomly drawn instance. Well, fortunately, all of those permutations and randomly drawn instances can be generated up front. And so what FastShap does is it generates all that data up front, and then there's no trickery, there's no advanced programming or C++ or other packages. All it does is it just uses R's built-in capability to do logical subsetting. So what it does up front is it generates all this data, creates all these swapped out instances up front, and then just calls the scoring function once. And so that's a very simple but thoughtful idea that ends up a huge gain in terms of computational saving. And so if you're not familiar with logical subsetting, here's a link to Hadley's advanced R book, a particular section in there. So that can complement what Shane talked about in terms of resources. Even though it's advanced R, it's still a very approachable and useful book, and it's free. So that's the big idea behind FastShap, and I'll show you some benchmarks on how a simple idea can really speed up the process. It's also parallelized across predictors if you still run into a bottleneck. If you're familiar with TreeShap, TreeShap is a fast and scalable implementation of SHAP that's specific to tree models. Typically, you'll only see it implemented in things like XGBoost and like GBM, but it supports that. And then I do have an implementation of force plots. If you're familiar with that, I added this as a call out to Alex's presentation earlier on Reticulate. So force plots are a popular way of visualizing feature contributions for a small set of predictions. It's only available in the Python SHAP library, and it's not easy to port directly because it's based on JavaScript. So there's an example in this package where I just use Reticulate to sort of not reinvent the wheel, but just call in that other package. So you can get these force plots working in Markdown. Okay, so that's the basic idea behind FastShap and how it sort of tries to attack one of the bottlenecks in that Scrum-Belge algorithm. Here's an example. Here's a simple benchmark FastShap compared to a couple other well-known packages that support that same algorithm for Shapley values. So this is explaining a single observation from a ranger-based random forest. If you're not familiar with the ranger implementation of random forest, you're really missing out. And how that fits onto the Titanic data set. And so the idea here is I'm explaining a single instance, and on the x-axis I have the number of Monte Carlo reps used to approximate. So the idea is with the Monte Carlo approach, the more times you replicate a Shapley value and average across all those replications, the more accurate and stable it's going to be. So you want that to be as high as you can. But the point is if you're using an algorithm that just does those sequentially and just computes them one at a time, that's really going to add up. And if you're doing this for more than one record, or if you have, hundreds of features, this time really adds up. And so this isn't to deter anybody from using, IML and iBreakdown are really fantastic packages that have a much broader scope than just Shapley values. But again, FastShap is meant to just address one particular bottleneck, and you can really see that really just speeds up the process in certain situations. So on to a quick couple of examples. So here's the same data set in that benchmark. So this is the well-known Titanic data set. You can, it's available in the Titanic package. So just a little bit of setup. In the tree book I have coming out, I pulled this example from there. I do a little bit more of an elaborate analysis with that and with the Shapley values, where we look at mice-based multiple imputation here. For brevity, I'm just sort of kicking out the missing values just for simplicity, but that's not always what you want to do. So the book kind of goes into a little bit more detail on how you might do things with Shapley and deal with missing values at the same time. So here's an example of using FastShap's explain function. So this is an example of where I'm providing Shapley-based feature contributions for an entire training set. So this would be a very cumbersome task using any of the other packages. It would take a long time. So here I'm refitting that same random forest. In this case, it's a probability machine. At the very least, with FastShap or any of the other packages, you need to have a prediction wrapper. This simply just tells FastShap how to obtain predictions from your model. In our case, we're interested in the predicted probability of surviving on the Titanic. And so this function just kind of pulls out that. It needs two arguments, object and new data. Then I need to supply a background data set. In this case, it's the training data without the target. And then, of course, there's some randomness built into this. So I set the seed for reproducibility. And then I run this. This takes about 10 seconds for the entire data set. So that's 714 rows times 7. And I'm doing 100 simulations for each. So that's a pretty good time, I think, for explaining a data set of that size. So here are the individual feature contributions for every row in the training set. By themselves, they're not all that useful, but these can be aggregated into global measures of model interpretability. So I do have some utility plotting functions in there. So for example, you can aggregate the individual Shapley values into an overall global measure of importance. So this is like looking at the mean absolute Shapley value. You can look at the sum. There's all kinds of things you can do with it. So this gives me sort of another way to sort of measure variable importance at the model level. If you're familiar with partial dependence plots and similar techniques, I can also plot the raw Shapley values versus the individual features. These are called Shap dependence plots. And so they can give you an idea of how the feature value sort of affects the SHAP output at a more granular level. And so as you might have thought with the Titanic, kids had a much higher chance of survival, women and children first. So this kind of shows that the SHAP impact for younger kids tend to have a positive effect in terms of pushing their predicted probability of survival up. And then as you get down into the older individuals, and you can color that by different features in the model, just kind of tease out whether you have interaction effects, so on and so forth. So we don't always want to explain like an entire training set. Usually we just care about explaining a small fraction of predictions. In this case, we'll look at explaining an individual row, or in this case, a passenger. So meet Jack Dawson. Spoiler alert, if you haven't seen the movie, Jack did not survive the Titanic. So I populated all of Jack's inputs based on the movie I saw in like the 7th grade. Jack was a 3rd-class passenger, male, 20 according to Wikipedia, no children or parents on board. Technically, he won his ticket in a poker game, but I put a small value here for that. Based on this input, so this is a new observation, Jack's predicted probability of survival is a measly like 9%. The average predicted probability for all the passengers in the data set was 40%. And so what we want to do is we want to understand what about Jack's features attributed most to this difference. And so we can get the Shapley feature contributions for that. A good way to visualize those is to use something called a waterfall chart. And the way I have this one set up is I have the probability of survival on the x-axis. Over here on the right, I have the average baseline. And on the left, I have Jack's individual prediction. So how do we get from this baseline all the way down to Jack's poor predicted probability of survival? And this just kind of shows you how much each feature and its value sort of pushed Jack's prediction from that baseline down to his individual score. And so most of them had a negative impact, except the fact they didn't have any siblings seemed to have a small positive effect. But this is one way to visualize how each feature contributed to that difference between the baseline and Jack's prediction. And so waterfall charts are a good way to visualize that. I think I'm almost out of time, so I'll just breeze through one last example. It's a little bit more interesting. I also took this from the book. I don't like the term prediction explanations because it makes you think that this only applies to supervised learning experiments, but in this case, this is an unsupervised learning problem. So there's a URL to this credit card, fraudulent credit card transactions data set out on Kaggle. So this is like 250,000 records, like 280,000 that are all labeled as either fraudulent or non-fraudulent credit card transactions. So I'm going to take that data. I'm only going to take 10,000 observations to build a model. I'm using something called an isolation force, and I'm not using the target, even though it's labeled. I'm not using the actual fraud label or not. So the idea is in an isolation force is to try to isolate anomalies. It's a really useful technique. I encourage you to go learn about it if you do this kind of stuff. But the idea is that even though I don't train it on any target information, what's produced by an isolation force are these anomaly scores. And they're kind of like, you can kind of almost treat them as a probability of being an anomaly. They're between 0 and 1. Scores closer to 1 tend to be more anomalous than the others. Most of them in this data set cluster around 0.32. So most of the observations are not fraudulent. And so they tend to have lower anomaly scores. But the idea is we can use the same machinery of like partial dependence, Shapley values to explain these anomaly scores just as if they were predictions from a supervised learning model. And so same setup here. The maximum observation in my test set had an anomaly score of 0.84. It actually is associated with an actual fraudulent transaction, but I can go in and explain this observation using Shapley values. Here I'm using 1,000 simulations. This only takes a few seconds, so it's a pretty accurate Shapley value. And then again, I can do similar things like look at a waterfall chart. It's kind of moot for this example because all the feature values that were anonymized using principal component analysis, but the same idea applies. So I can still use this to explain, well, why was this observation scored as much more anomalous than the average in my population? And you can see, well, because the amount was, of the credit card transaction was like 26,000, so on and so forth. And so the idea applies more generally than just supervised learning models. There's a lot of cool stuff you can do with these. And then I'll stop there. A couple of good resources, Interpretable Machine Learning, free open book by Christophe Monar, who's also the author of the IML package. We're also collaborating on a Shapley value paper for the R Journal, hopefully early next year that'll be out. And then there's this explanatory model analysis, a newer book by the creators of Dalek that's also freely available. And they go into a lot more detail about this stuff and these individual packages outside of FastShap. And so thanks for your time. Any questions?
All right, thank you so much, Brandon. Yeah, there are questions, but we're over time. So I'm going to ask you, so if you just look in the chat, there's multiple questions. So if you wanted to answer those in the chat, that'd be great.
Yep.
So we're at break. So I right there at the end there, I ran to my other computer and ran my script. So there were 26 eligible participants and the winner was Alec Wong. So Alec will be in touch so that you can get your book from George. So we'll coordinate that afterwards, and you both know each other, so you could probably just do it yourselves, but we'll try and make it seem more official here. A reminder that well, Alec, I will not let Alec win again, but anyone else who is, of the 26 who are already eligible, will be eligible again, plus anyone new who talks in the chat for the evening session. So we're going to be back at 1 o'clock Eastern. We're going to continue the machine learning theme with Jay Cunningham's talk on Cat Boost. So please go take a break, get some food, walk around. I will ask, can everyone turn their videos off? Because I'm going to try and resurrect my the Zoom on my other computer. So I just need as little activity as possible. So if everyone can turn off their videos for the break, and we'll see everyone back at 1 p.m. Eastern. Thanks, everybody. All right, Jay, while people trickle back in after the break, do you want to make sure you can unmute yourself, share your camera if you like, and also can you share your slides? I want to make sure you have get enough time for your talk.
All right, can you hear me?
Can hear you great.
All right, let me see if I can share my screen. I've never shared with Zoom before, but let me make sure I'm getting the right one.
Yeah, and if you're on a Mac, you might, if you've never given it permissions before, on this computer, I had to restart.
Oh, shoot, okay.
So it's okay if you have to log off and log back in real quick, just do that real quick.
Okay, let me see if I can make that happen. All right, yeah, it's going to quit and reopen Zoom. So let me log back in here.
Okay, great. We'll be here.
Okay.
All right, while we wait for Jay to come back in, so I just posted our website. So there's all the information about how the rest of the day is going to go. It's got our code of conduct on there as well. We've got a nice session coming up, a break, and then we'll have our keynote, Nick Wan, at the end. We already did our first book raffle, so a reminder, if you enter anything in the Zoom chat, you will be entered to get to the full screen. Sorry, you'll be entered into the book raffle for George Mount's Advancing Analytics book raffle at the end. Okay, Jay, we can see your screen. Can you share do you have a intro slide?
Can I what?
Do you have an intro slide you can show?
You know what? I did not.
Okay, that's okay. That's okay.
Briefly, I'm Jay Cunningham. I am a data scientist at 8451.
Wait, let me hold. We have to have a stop so that when we edit the videos later. So I'll introduce you, but let's just have a pause here. Okay, so Bernie, this is where you'll pause for this one. Okay, so next up we have Jay Cunningham. He's going to tell us all about CatBoost, a new machine learning model. He's a data scientist from Cincinnati. So take it away, Jay.
All right. Hey, yeah, I'm Jay. I work at 8451 as a data scientist. And I'll be talking about categorical variables with CatBoost now. And got a lot to cover, so I'll just go ahead and get started here. If you want to follow along, you can go to bit.ly/catboostr-intro, which is where the slide should be. And let me go ahead and open those up. All right, can you guys see my slides here? All right. So categorical variables with CatBoost. So the problem. So you have a supervised learning problem, you have tabular data, and the tree-based approach seems like the best fit. Tree-based approach is really good for tabular data, but you have a categorical variables, specifically here, it is an x sub j, some index j, with a reasonably high cardinality, no ordinal interpretation. So, just encoding it with an integer index or something would not necessarily be appropriate. Define the best split for xj. So you're building a tree, or you're building mini trees maybe, but you're building a tree. You want to find the best split for this categorical variable. In principle, that would require examining 2 to the k minus 1 subsets of the set of categories included within x sub j. There is a neat trick for this. We'll get to that in a minute, but you might already know that. But in general, that's pretty computationally intensive to do. In fact, if you had more than 100 to 200 categories, it would just be completely impossible. Some libraries like XGBoost and scikit-learn, and I'm a Python guy rather than an R guy for the most part. So this is kind of where I come from. XGBoost, scikit-learn, they just punt right now. So you're responsible for converting x sub j into a numerical variable somehow. Some libraries are cleverer, particularly R libraries, but we'll get to that again. And even libraries that do handle categorical variables cleverly, like Ranger and LightGBM, don't do that by default. And LightGBM in particular has mixed messaging on whether you should use its functionality. So you're preprocessing categorical variables. If you want to preprocess it yourself, you have a few options. You can one-hot encode x sub j. You can convert it to k individual binary features for each category. Not necessarily a good fit for tree-based approaches. For high K, you can introduce a lot of new features, which may not play well with feature bagging. The binary indicator for each category K will be sparse and unlikely to be chosen for each split, even if the underlying variable is informative. You can label or ordinal encode X sub j. You can convert it to an integer with an arbitrary ordering. And you can do this. A lot of people do this, but it's unlikely to find the optimal split. There's other kinds of encodings, like you can code it by the number of times the category shows up in the data set. I think Data Robot likes to do this if you use it. It's not likely to choose the optimal split, but again, it can work. Also, you might use categorical embedding, but then you're stuck training a deep learning model, and that takes a lot of time and money. Though, if you really want to go that route, I think it's the embed package makes that pretty easy. Another option, so maybe you've used random forest or GBM before. These are our libraries. And you notice that they handle factors without complaining. You give it a factor, it just does the right thing. So as long as they're below like 53 categories in random forest case. So what's going on here? What are they doing? Turns out there's a simple trick that gets you the optimal split under general assumptions. You can just order the categories within X sub j by the mean of the target at that node, and treat the result as a numerical variable for the purpose of splitting. And more generally, you can compute the target statistic. This is just stolen from the CADBoost paper, which I'll go back to, or I'll have a slide with links, and you can find that paper and read over it yourself if you'd like. But you replace category K for variable X sub j with X hat sub jk, and this is just basically a mean of the target with the prior P. Libraries that do something like this, not necessarily exactly this, but are like random forest, GBM, Ranger, but not by default. Ranger has other ways of handling categories as well. A light GBM, the light GBM does something a little different. It actually orders by the gradient rather than the target, and I'm sure there are others that do the same thing. So what's the problem? You might be familiar with target encoding, and that's essentially what we're doing here. And just like target encoding, this can lead to overfitting. So essentially, that distribution of X hat that we've estimated with a target statistic, given Y, differs at training versus test time. And so you can see the CADBoost paper for a simple classification example. And in this example, all the training observations are perfectly classified, but accuracy is only 0.5 at test time. That's a really simple example, but it shows its existence proof for the fact that this can be a problem. In general, they identify this property that you want your choice of target statistic to obey, and that is that the mean at training time equals the mean at test time, essentially. And so what does CADBoost do? They take a cue from online learning by defining a synthetic ordering, so a permutation sigma of the training examples. And then for each example L, they use all available history to compute the relevant target statistic, basically computing the target statistic for all observations for which that ordering falls below that for sigma L. And that satisfies that property P1 while using the entire data set for training, which is another property that they identify as being desirable. So to avoid higher variance for earlier training examples, because if you look at this, if you use the same ordering every time, you're not going to have a lot of observations for the items that are low in the ordering. They actually use different permutations at different steps in the process. What else does it do? So that's not all it does. A couple other things that they do. They actually address another source of bias unrelated to its target encoding, what they call prediction shift. The gradient in each iteration is estimated using values of the target at the same data points that the current model was trained on, while the distribution of F differs at training versus test time again. And this is really breezing over it. They go into a lot more detail in the paper. I recommend reading that if you're curious. Conceptually, they address this by estimating different models for different sets of data and computing residuals, for an example, by using a model that's trained without that example. It's actually a bit cleverer than that because that would be kind of computationally intensive, but their algorithm is described in the paper. And finally, CADBoost builds additional features by combining categorical features in a greedy fashion. Wow, I have a lot of spelling mistakes in this. I apologize. Considering only the features used in previous splits. Actually, that's a little misleading. I mean that they consider the features that appeared in previous splits combined with any of the categorical variables in the model for potential combination features. Drawbacks. So big one here. I mean, depending on what your priorities are, what your restrictions are, it's not available on CRAN. It's actually an open GitHub issue since 2018. I'm not holding my breath. That's going to change anytime soon, though they're aware of it, and there was some initial work toward it. It's also not installable via like a remote install GitHub. They're not structured that way. So basically, I'll go through an example if I have time in a second, but you have to go and find the URL for the actual binary or download it yourself and do like rcommand install. Also, its documentation is not great. This comes from Yandex, I guess, which is the big Russian tech company. It's like Russian Google. And I think there might be a bit of a language barrier in some of the early documentation. So some functions have no examples, particularly in the R, which is maybe R is a little bit of a second player to the Python version of CatBoost. There's jargon they never explain, like what's a CTR? You might know what that is just by looking at it or me saying it, but I didn't because they spell it like this. I didn't even know it's an acronym. And there are parameters whose values depend on other parameters in complex ways that are poorly explained. So, if you want to try to find out when exactly categorical features will be one-hot encoded rather than using the clever stuff I described before, and it's not clear from reading the examples. You have to go flip from bit of documentation to another bit of documentation in a way that is just it's a little bit frustrating. All right, examples. So I'm going to go back to my thing here, and I'll go through a basic CatBoost example real quick. Excuse me. Increase the size here. So CatBoost isn't on CRAN. So this is basically how you might install it. You can find that you go to the GitHub page, you go to releases, and you actually have to locate the most recent version, which is, I'm on Mac. So I find the Darwin release and give it the URL and just do a remote install URL with that. You can also, again, just download it yourself and do like rcommand install. While you're at it, you might consider installing TreeSnip, which I'll get to in a minute, maybe, which allows you to use CatBoost and LightGBM with tidy models if you're into that. So just go through an example here. This is the Ames housing data set. You might be familiar with it. The nice thing about it for us is that it has lots of categorical variables. It's lots of factors, 46 of them. And so you have to, every function in CatBoost is like CatBoost dot something. You have to convert your data to these pools. So you do CatBoost.load pool. And then it's just like training. It's a lot like training LightGBM. You give it your parameters, your loss function, RMSE, custom loss, R2, so R2 as well, R squared as well. Give it your number of trees and your depth and your learning rate, and you CatBoost.train. And it's very straightforward to train a model that way. At the end, it'll give you the message. It'll say, oh, your best iteration was 492. So you can use the CatBoost.shrink to shrink it to that. And then you're good to go. Find predictions with CatBoost.predict. And, you can use the eval metrics to get, R squared for various iterations. It also does feature importance. So you can do feature importance here and get feature importance scores. So we say the GR live area is the most important variable in the model here. You can use CatBoost.get feature importance for other stuff, including SHAT values, which you learned about earlier today. I think these are exact SHAT values computed with via like a tree SHAT method, but don't quote me on that. Other useful functions, so you can do CatBoost.cv for cross-validation. And there's a CatBoost.caret. You can use that if you want to use caret. Real quick, I will go and look at this tidy example. So if you're using tidy models, this is how it would look. When we see the slides, or the end of the slides, you'll see, you can look at this if you want to. I actually stole the idea of this from another website and kind of cleaned it up a bit. But basically, you have to set dependency for TreeSnip and CatBoost so that, they play well with parallelization. And then, you just do everything you do for tidy models process. You make your recipe up, and then this is the bit that differs for cat boost here. You have various parameters you can tune, like learning rate, etc. And you say the set engine, cat boost, and you give it your loss function, which is any of the loss functions that cat boost supports. Basically, I don't have time to really go through it. Maybe you know how to use tidy models, but this is how it looks. So I ran this, using cat boost's method of handling categorical variables versus just one-hot encoding. And you get a little bit of an improvement. It's actually not as dramatic as you might think, but it does improve RMSE about 2% and mean absolute error by about 10%. Let's go back to the slides. Conclusion, cat boost is worth exploring. It is a lot faster than XGBoost in my testing and testing I've seen elsewhere. It gives good results. It has a clever way of dealing with various things. It's not always the best. And I think if you really tune a model with XGBoost or Light GBM, I think you'll probably get better results than you would with cat boost. That's my estimation, but it's definitely worth considering, especially because it's so fast. Here are some links. You can do the bit.ly for any of these. So the cat boost paper is available here. The cat boost website is cat boost site, cat boost params for training parameters, and other things here, like comparisons between the cat boost, XGBoost, and Light GBM. And that's about it for me. Any questions?
Thank you, Jay. Well, first, real quick, Brandon did in the chat confirm that it's using Tree Chap.
Good.
That you were correct there. But there's no questions yet. So one thing is, if you could send, I couldn't find that GitHub repo you kept going to. So if you're willing to share that, I put some of the links in there. But yeah, this one.
Do you want me to share that in the chat, or do you want me to share?
Yeah, I think it'd probably be easy for people if it's right there in the chat, because this is a really great resource for a really cool tool. So I'm sure there'll be lots of people who are want to try it out.
There you go.
Okay. Do you want to just read the question real quick? Well, I'll read it out loud, but you should probably look at it too. Alec has a question here. The viewers.
Sorry, Alec. Okay. New to categorical encoding, and I was wondering if you could comment on the relative difference of something like this. Something like this. What is this? I'm not sure. I'm not really familiar with GLMM, so I'm not sure I can really comment on that. Yeah, I apologize.
No worries. It was just a shot in the dark.
Like, you also get the prize for the most well-researched question. Drop in documentation and a link to the PDF, the preprint. Very, very nice. So Jay, you can take a look at those links later. If there's no other quick questions to keep things moving along, I'm going to pass things off to Abbas. So thank you, Jay, and thanks everyone for the questions.
Hey all, I will be kind of emceeing the next two speakers. We're really excited about our next speaker, Michael Kearney. He is a data scientist at Aware. Recently joined from academia. He's also the author of many R packages, some of which you may all know, like R-Tweet or Googler, and he has some API related stuff with like the New York Times, Kaggle, so some really cool stuff. He's going to be, I'll wait for him to share his screen here, but excellent. So yeah, well, without further ado, I'd like to welcome Michael. We're looking forward to your talk on NLP and text-based modeling.
All right, thank you. Can everyone hear me? Hopefully. Okay.
Yeah, we can hear you.
Yes, yeah, yep.
Okay, so thank you for that kind introduction. I'm excited to talk about the current state of natural language processing and text-based machine learning modeling. As Abbas mentioned, I recently left academia, and I've joined industry to work as a data scientist, and has caused a great amount of reflection on kind of what is a data scientist, what do they do, what are kind of the real world applications, and in what ways might R be advantageous compared to Python and vice versa. So this will maybe reflect some of that as well. So what I plan on doing, I'm just going to talk through kind of different parts of NLP and machine learning based on text, from the data collection process to the processing, modeling, and then I kind of got some opinionated takes on the future of NLP. But first, I do want to thank the heavy lifting packages that obviously have uses outside of NLP and text-based machine learning, but are nevertheless important here as well. And these are the packages that usually don't get as many mentions because they're not the interface that most users might use when they actually apply the modeling, but they're almost always used behind the scenes. So data collection is really exciting in R. As the boss mentioned, I am the author of R Tweet, so I had to throw in a reference to that, but there's super easy to use R packages to quickly set up workflows of web scraping or working with web APIs where you can do it extensively. And you can, they're just really nice to work with. So XML2 and RVest in particular for web scraping, and HTTR and JSON-Lite packages that I feel like I've written 20 or 30 different R packages that are just wrappers around HTTR and JSON-Lite, because once you understand the basic ways that web APIs work, it becomes quite easy. There's also obviously more and more public data sets that are available that have text or natural language shared on academic libraries, Kaggle, data.world, published on places like Zenodo and others. And the kind of newer area might be the more and more accessible video and audio data, as well as the natural language or transcripts along with those. Data processing, fortunately, a lot of the complications that have come up recently are related to Unicode, and those things kind of get addressed behind the scenes by like a major update to a programming language like Python 3, or more behind the scenes with packages like Stringy and R, which do a great job, I think, of handling that. And then a lot of these encoding things kind of fade into the background that we don't have to worry about too much in R. Data processing also works with a lot of different formats that are native or that are more specific to R, data.table or data frames in general, data.table, tables, as well as matrix and S4 class type objects. There's also a number of ways to go about tokenizing, so splitting natural language into sentences, words, paragraphs, etc. You can use that with regular expressions in base R or with stringer. And you can also implement tried and tested algorithms very easily with packages like tokenizers, TM, and Quantita. So I like to think of NLP type models as either being an implementation of some kind of predefined dictionary where it's kind of a crude lookup to see what words or phrases are there and then give some kind of points to represent the text document in some way numerically. Or there's machine learning models that are built on supervised methods where they have labels, they're trained, and it generates weights that you then use to predict an outcome or class, or unsupervised, which is, I think the big area is topic models that has a lot of room to grow. And I think an interesting place for R to potentially develop more and more solutions for. So that's my quick overview of kind of what's there with some packages. It's not exhaustive. I know I've left out a ton of packages. I'm not even going to pretend that I have the best survey of them, but I thought I would at least share ones that I commonly use and that seem to be popular, that at least I could quickly identify. So I kind of wanted to show the last month or two of downloads, daily downloads of a number of packages, many of which I've already talked about, but just to kind of get a sense of where they are. So we have Stringer and Stringy. Both have relatively the same amount of downloads as RCPP, which we all probably know is quite a few. So we're looking at over 30,000 downloads a day recently. And those are fundamental packages that are easily incorporated into a lot of other packages, so it kind of makes sense. Data collection, web reading, or web data reading packages are also used pretty extensively. JSON Lite in particular has some very high daily download counts, as well as HTTR and RVS and XML2. Some popular NLP framework type packages would be TidyText, TM, and Quantita. And you'll notice here tokenizers kind of follows along with TidyText, and I think they tend to have similar uses, or they tend to be used together. But tokenizers also seems to have applications outside of the TidyText framework. But these kind of give you a sense of where these type of frameworks are being downloaded as far as download counts. So we have around 2,000 a day for a lot of these, whereas going back to the web reader type download counts, it's well over 20,000. So we have a lot fewer of these, and this is kind of where I think there's all sorts of room to grow, or at least consideration should be given for future development of R and advancement of packages. For sentiment and dictionary type packages, we have a similar download counts. TidyText does a pretty nice implementation of many of them. My favorite is the Suizet package, which I always forget how to spell, so I always get a little frustrated with, but then it's so easy to use. I enjoy it quite a bit once I remember how. And Quantita, which I do want to kind of give a plug here, that I think that I'm a big fan of TidyText. It incorporates tidy data principles into an NLP workflow. So it makes, if you are good at dplyr, you can very easily be good at working with text data, which is nice. But I would say that Quantita is the more versatile, more fully developed, very robust and powerful text data framework package. And it's starting to be broken into modular packages of text stats, text plots, and text models. But the use doesn't seem to reflect, I think, the work that and the quality of the package itself. And part of that might be that it doesn't reflect some of the easy design principles that users tend to be drawn to. But I figured I'd at least give it a quick plug for a solid package. There's a number of topic model packages that are great. Text2Vec is a very fast implementation. Topic models is good, as well as LDA and STM. But we'll notice here that the download counts are even lower, down at around 300 per day, despite these packages being solid at what they do. Neural networks are still lower, a lot of these packages. So Spacey is probably one of the leading frameworks for developing text-based machine learning models, and that is a Python package. There's an R wrapper for it, as well as like Keras and TensorFlow have similar. A couple of the native implementations of neural networks that could be used in this context would be RNN and Rumitol. I'm not sure how to pronounce that. But you can see that those download counts are pretty low. And in part, I think a lot of that is because it gets gobbled up by Python. So R definitely has a space, I think, to make a contribution. And but realistically, it is quite far behind in the deep learning architecture area. And I think that the future of NLP and text-based data packages should kind of keep that in mind about how to operate at kind of a high level to offer our users an easy framework, while also kind of providing a realistic path forward for why the packages might be usable. So kind of talking a little bit about the future of text data, I think that models will continue to get bigger. Deep learning models will have more and more layers, more and more parameters, and that will eventually happen or continue to happen until there's some kind of quantum computing breakthrough, I'm sure. Google has published a paper that kind of outlines the theoretical gains that could be taken from increasingly complex and large models. So here on the left-hand side, the plot shows that for relatively small data sets and highly complex ones, there's not much to be gained over classical machine learning, but as the data sets gets larger and more complex, there is more of a difference and theoretical advantage to quantum computing there. But we're still having a difficulty in even understanding what that might actually look like. I also think that the future of text-based machine learning models is that they'll get smaller because people are, I think, are now interested in more efficient implementations of models. So rather than having 1 million parameters, how can we do this with 1,000 parameters, but still have a similar performance? As well as like more realistic implementation questions, like how do we have a device-based deployment, like something on a phone, or user-specific weights. And hopefully these models will continue to get better as well. I think we are now starting to identify and understand the different ways, some of the different ways that biases and inputs and training data tend to manifest themselves afterwards, and we're more mindful that that is an inevitability. I'm hoping that that will kind of continue to push theory as one of the solutions to the bias problem, is that theoretically driven decisions instead of simply empirical ones might be beneficial. And then transfer learning, which is something I didn't talk about directly. One of the cool breakthroughs, I think, in recent NLP is the transformer models that have been trained on generic, like a masking technique, which is cover up one word and then try to predict that word using the context around it. And those ones are really powerful because it kind of develop these latent dimensions that seem to be applicable across different tasks. So combining those with ensemble models would be a place as well. And so where I think R fits in the future is, I think we can definitely leverage the R's big advantages. It's more approachable programming language, which I think allows it to attract broader, more diverse base of users. And by more diverse, I at least mean more big picture abstract thinkers than perhaps some more computer science-based languages. And I think there's an emphasis on more high-level functions and interactivity, which allows for quick demonstrations of proof of concepts, quick uses for data science purposes of exploration or for analysis, and that the most efficient implementations might be done by data engineering in a different language, but in the space of R for finding out, designing, and drawing up different types of analyses, it still seems like this could be a great place for development. So that's it. I'm hopefully not way over time. I lost sight of my computer clock. So yeah, that's it. I'm open to questions.
Awesome. That was a very informative talk. It was really great. I'll kick us off here. I was just curious if you knew of any like nice R integrations with like libraries like the Hugging Face library or that suite of tools.
What was the example?
Like Hugging Face, like the transformer models, like Bar,
yes,
Albert. Yeah,
there's Arbert, which is I thought was a nice implementation. And as I recall, their documentation kind of says like you can do fine tuning with this package, but we don't recommend it yet. And I think that's kind of the problem that we run into with some of this, is that some of these models are so large that an easy implementation in R is, at least for the typical type of use in R, is something of a difficult task to do. And a lot of these are written, not even in Python directly, they're written in other languages, and the Python library is the immediately accessible high-level implementation of it. So I would like to see more and more of these. I probably need to familiarize myself with some that have been made since, but of course, since BERT, there have been advancements and improvements, different type of transformer models, and I'll just leave it at that. But it sounds like I should at least check out. I don't think I've heard the Hugging Face one.
Yeah, I think they're a startup based out of Paris. They're doing a lot of great work. You should definitely check them out. We have another question here asking about topic modeling, and I know personally I haven't had much like amazing success with it. We were curious if you had some like insights, if you were able to derive meaningful topics, and if you were able to gain some insights from like this unsupervised task.
No, so this is especially I've worked a lot with Twitter data, obviously, and at least for tasks where you have relatively short messages, it's the results don't look pretty. I think the default ways of kind of doing it, and in part, I don't think that's necessarily a limitation in the analytical techniques as much as it is language is messy, and they're, it's hard to capture perfectly the meaning that is being conveyed because it's pretty subjective, both on the meanings intended by the speaker and the meanings interpreted by the receiver, and not to mention all the noise that happens in between. So we're kind of asking something like topic modeling or a clustering type of algorithm or technique to do a lot. And that's why some of these transformer models show, I think, some potential for working with topic models where I can take one single tweet, for example, and get 10 million parameters based on a pre-trained transformer model that was used on Wikipedia data or on Twitter data or whatever. And that might be the way forward. But I do think that topic models, at the very least, the kind of simple implementation ones that are easy to do, are still useful for identifying some like big topics that might exist. So a lot of times you can find one or two topics that seem to have consistent meaning throughout the top words in that topic. And I think that cherry picking is like fine in that case, to kind of say like, here's some empirical evidence of at least these type of topics appearing. And I don't think you have to necessarily be held accountable for like the sixth topic that shows up that appears to be completely random.
Awesome.
Assuming you're transparent about all of that. Yeah.
We have a few more minutes. I don't see any additional questions rolling in, so I could just fire off another one unless someone else wants to jump in here.
So I had a question that I've always tried to answer. I work at Progressive and we deal with survey data. How do you deal with sarcasm? It's like, some people will be like, Progressive is a great insurance, not. I'm like, so you will have like scores of like, this is a really good comment, but it's technically, when you read it, sarcasm, so it's not, which I have no idea how to deal with that.
Yeah, so, and that is the question, right? And so in the example you gave, that might be one of the easier examples that we could expect an algorithm to detect, right? Because at least there's a clear indicator at the not. Mm-hmm. But like a basic algorithm would look at that and it would be difficult to discern. So obviously some of the advancements have been to not just use single words, but to use embeddings or n-grams of 2 or 3 words per token, and that kind of space allows for a more abstract understanding. And then in theory, you could have the interactions between two of those. So maybe there's kind of the sarcasm indicator, like not, as along with the concept being discussed, and the interaction is something different than the actual concept. That's where those transformer models come in, because the task that they are trained on is you take a sentence, you hide one word, and then you use that sentence to predict what that word is. And another task that they're trained on is to predict the next sentence that follows. And that both of those, we know the answer to those. It's not like we've assigned some label to it. We know the answer, and training on that should, in theory, be able to come up with all these abstract latent dimensions that might explain all these. The problem, of course, comes into there's no universal understanding in both how to communicate and how to read or how to understand that communication. So you're always going to have like a pre-existing relationship with someone where you can very easily insert some sarcasm that no one would have a way of knowing if they didn't know you before.
Yeah, it's a whole problem that we have to deal with, where like we'll try to like get different states and get them like, here's how good your surveys are, and the argument is always, how can you understand millions and millions of comments that people leave on their claims? And it's something that we report out on, but people don't take it as serious as we would like to, given that there is the whole like, how do you understand if the person's being, if it's a happy comment or not? But thank you.
I will say that in my experience, so I've kind of been there with like, I have concerns about those obvious cases that are categorized the opposite of what they should be, or that are clearly overlooked in that. But then I see that still the vast majority of cases are relatively straightforward. So if you do like a basic sentiment analysis of tweets, the top 10 tweets out of 100 look like more positive, the bottom 10 look like more negative, but there's always one outlier or two outliers here or there. And I found, at least, so I built a bot classifier for Twitter data to try to detect whether any given account or any given tweet is done by a bot. And in my experience, one of the best ways to improve those models dramatically anyway is to focus on those potential false positives or potential false negatives. And that would be kind of digging down into those type of cases to figure out, given the context in the media, what can be done to make assumptions that would improve those type of classifications. So that's an exciting area, but one that I'm afraid does not have a universal path forward or solution yet.
Definitely. Thank you.
And yeah, if you are interested in NLP or data science challenges like the ones I've talked about, we are hiring. So there's a link in chat.
Boss, you're muted.
Oh, excellent. I said, well, thank you, Mike. We're going to move on to our next speaker, Julia. Julia.
Okay, I will go ahead and share my screen. I apologize in advance.
Sorry, Julia. I'll just quickly introduce you. So Julia, Julia is a data analyst in the United States Air Force. I think she's located over in Dayton, Ohio. So she'll be presenting her Shiny app called Slang today. So that should be pretty awesome. So we're looking forward to it. Welcome, Julia.
Thank you, sir. I apologize. My camera is not working today. So rather than sharing a frozen screen, I decided to just keep it off. So I will share my screen here. Please confirm when you can see that.
Yep, we can see it.
Okay. So I will be presenting this Shiny app that I built. I called it Slang. It's kind of a forced acronym for Surveys, Linguistics, and Analysis Knowledge Guide. So the N in knowledge is the one that's capitalized there. So like you mentioned, I work for the United States Air Force, which means that we kind of have a hand tied behind our back in a lot of instances. Like, for example, we don't have access to Python on our machines, so we can't use Python to do some of this kind of data analysis stuff that we've been tasked with lately. So I just completed my master's from the Air Force Institute of Technology in Operations Research, and I did my thesis on sentiment analysis. So Michael Kearney's talk, that was really, really neat. Kind of blown away by some of the NLP stuff you were talking about. So thanks for sharing that. So essentially the crux of why I decided to build this was because our office was being tasked with a lot of analysis of surveys, which is something I think Andres just mentioned, asking about survey analysis and sarcasm stuff. That's stuff I've dealt with a lot lately. So essentially when the Air Force has been asking people to fill out kind of customer analysis surveys of how people are happy with the workforce or their bosses or their offices and stuff like that, then my office had been tasked with a lot of that analysis. And in watching some of the approaches that people were taking to analyzing the text side of things, essentially their go-to was just word clouds, and that was about it. So I was like, I think we can take it a step farther. So I will go ahead and share the app here. I can move that. Okay. So here is the app. I'm gonna get rid of this. Does anyone know how to move this bar here? Oh, there we go. Okay, so this is the Slang tool, and essentially I built it so that it was extremely explicit because my kind of goal customer here was going to be analysts who are not specifically trained with or kind of run up on sentiment analysis or topic modeling or any of that stuff. So while there are kind of more advanced techniques and methods that I could have implemented in some of this, I knew that if it wasn't highly explainable and highly interpretable, then it would kind of not go super far. And I wanted people to be able to use this and be able to explain how they got the results that they did to kind of senior leaders who also don't have a ton of familiarity with what sentiment analysis is. So outside of this instructions, this just kind of tells you what the tool is able to take and what kind of data it's expecting. But essentially, what the crux of it is built for is just like an Excel sheet with a column of text that's relating to responses from a recent customer survey or employee satisfaction survey. So I thought that I would just demonstrate the tool rather than having slides. So I apologize for the kind of break in norm there, but I thought that this would be a more efficient way to kind of demonstrate what the Shiny app does. So essentially, if you upload the data, I had pulled some tweets, and I'm sorry I did not use the R-tweet package. I just pulled some tweets from a Kaggle data set. But essentially, this is a list of tweets, and that's what we're assuming that the user has is just to the tweets. They don't have sentiment scores, they don't have topic modeling, they just have the tweets. Or in a different case, it would be responses to an employee survey. And another reason why I had decided to build this is because kind of a sister office to the one that I work in had been spending like a month reading through manually and kind of annotating customer responses and employee responses with a positive or negative indication. And they were spending a lot of time doing that, like multiple man hours, a lot of people kind of dedicated to only that for 2 weeks. And, you know, while I'm sure that was more accurate than an automated approach, they certainly weren't happy about being tasked with doing that, especially because, of course, surveys have negativity bias when you're asking people about their jobs. So not the most uplifting task to be assigned if you're the one who has to read through all of the things that people have to say about their job. So anyway, this also has the ability to take in a PDF or a text file. So if we have time, I also have a text file of both Hamlet and the Avengers script. I think the Avengers script may be a little bit more interesting than the Hamlet one, but those are also kind of capabilities that I built into this. So for the demonstration, I'm going to name the data SatRday. And then I also built in a profanity filter because this was built for interpretive, like to be able to interpret customer survey and stuff. And people tend to use profanity, but people don't technically want that to end up in an official set of slides. And so I built in a profanity filter. Right now it changes profanity to a better word, but I also have a toggle that allows it to just kind of blur out the profanity altogether. So if I toggle the profanity filter there, it changes some of those. And then with the remove names, similar to the profanity, if somebody's mentioned by name, they don't necessarily want that to go further than the people who are taking the data, because we don't want to kind of invalidate the assumption that if you respond to one of those surveys, you'll be kept anonymous. So for example, if I wanted to any mention of Ron James, then it removes his name there. Same with James, stuff like that. So that kind of allows them to present the results of surveys without calling out anybody by name, unless of course they deserve to be called out by name if they're being complained about or something like that. So then I'll go over to the general overview. This is just unigrams, bigrams, and trigrams. It'll take a minute to, there it is. And these are all hoverable since I put them there with Plotly, so they're downloadable as well as a PNG. And then I also have this button down here that allows you to download unigram, bigram, and trigram counts into a CSV file. But similar to the removable names, I also incorporated the ability to remove the stop words and stop phrases. So for example, if HTTP or .ly aren't useful to you, you can remove those live there. And then with the bigrams, you can also remove stop phrases. So you can remove the HTTP dot. And then if you really don't want Malcolm Gladwell in there, you can remove him as well. Yeah. So that gives you the ability to kind of adjust these charts as you see fit. Since, for example, when we've been doing survey analysis of Air Force things, people tend to mention the word Air Force or the phrase Air Force. So being able to remove those was something that I thought would be a worthwhile capability. And then those are reflected in what you download as well. So that was just a way to kind of dynamically make those charts. It's also in a table and a word cloud, and you can adjust the frequencies that you're interested in here. And then the name of whatever you said your data was appears here as well, so that if you download it as a PNG, then you can remember what that was relating to. So then I'll bring it to the next tab, which is sentiment analysis. Sometimes, if they did spend the time to manually go through and analyze the sentiment, then if they upload a file that has a column called sentiment, then it will recognize that. But this one was just the tweets, so I'll tell it that it does not have sentiment analysis. And then I gave them the choice of all of these different sentiment or like lexicon dictionaries with a description of each so that they could make kind of an informed choice. Since a lot of the time I was seeing that people were kind of finding the first package they could or the first function they could in R, throwing sentiment analysis at the wall and saying that it was a degree of accurate that I think it definitely wasn't. So this at least gives them the ability to choose a lexicon based on what they think their data is going to reflect. So like the Lewin McDonald is specifically for financial kind of data. The Vader, I think, is the most recent in this list. So it links all of those as well. If they have a GitHub page that's actively kind of kept up, then it links to that as well. So then they can keep kind of an informed choice. And then I also enabled the ability to upload custom lexicon. And then they can upload that in the form of a CSV file with a list of positive and negative words. But I warn them to not do that unless they're familiar with sentiment analysis techniques. And I do realize that there are many more things that I could do here. For example, demonstrating negation words and adjusting the valence of certain words and kind of going a step deeper. But like I said, I was trying to value explainability and interpretability since I knew that if this was too complicated, then they would kind of stop using this altogether and go back to what they were doing before. So that's what I was kind of aiming for, is for them to make more informed decisions about what their sentiment analysis was doing. And then for topic modeling, this does not use clustering or LDA or anything like that for topic modeling. Like I said, I was highly valuing interpretability and stuff like that. So instead, I encouraged them to upload a topic definitions file, and I'll show you what that looks like here. But essentially, it's just they can define topics based on their own set of keywords. So within those tweets, the keywords under Nike, I had as shoe, foot, feet, sock, the phrase just do it, and Nike. For under LeBron, I had basketball, James, jump, ESPN, sports, NBA, and his own name, LeBron. So I just defined 5 topics here based on keywords. So those were Nike, LeBron, Kindle, dentist, and eating. And those were just kind of 5 key topics that came from the tweets that I pulled. So as long as they upload a data file with the column names as whatever .topic with the keywords under that, then they can say that there's no manual topic modeling. They can upload their topic definitions file, and then it will come up with the distribution of those topics from the tweets or from the survey responses that they were assigned to analyze. And then they can include the sentiment based on whatever dictionary they chose on the previous page. So then they can see, what percentages of the eating topics were positive, negative, and neutral. And then finally, I have a table view where they can include the sentiment and the topics, and then they can download all of that data. So then they can relatively quickly take, survey responses, apply sentiment analysis and topic modeling with a higher degree of interpretability and understanding of what they're doing. And then here they can also color code that table. And then finally, because not all analysts have R on their computers, R kind of jumps on and off what we call the approved software list. And sometimes when it jumps off, they have to take R off of your computer for a few weeks before they can put it back on. It's kind of a headache, but we can't always rely on R being on our machines. So I enabled the download of an HTML product, and it takes a minute to download. So I just had an example of it pulled up here. So this gives you all of the charts that the previous one had in it in an HTML instead of the R Shiny app. So that way that they don't have to depend on having R on their computer, and they can export the tool to people who don't have R to be able to kind of play around and look before they want to dive a level deeper. So that's the R Shiny app that I built. I'm so impressed by some of the things I've heard today. So I thank you for taking the time to listen to the tool that I built. And I'll take any questions if I have the time.
Yes, you do. You have like about 3 minutes for questions. That was really awesome. Really good overview of your tool. So that John just actually asked the question that I was thinking of, and it's actually about, do you have any strategy of like deploying the Shiny app? How do you share it among colleagues? Do they have like web-based hosting in the Air Force, things like that, or are you transferring this around locally?
So I have plans to present it at, we have an operations research analysis Friday forum once a month. So I plan to present it at that. And then if anybody is actively working on a survey analysis project, they can reach out and ask me for the most recent version. And then we do have a web-based kind of SharePoint platform that they'll be able to download this from if they have R on their computers.
Awesome. I was wondering about your topic modeling, and you showed that basically you have to manually create topics and have associated vocabulary with that. To be associated or assigned to a specific topic, did it just need an occurrence of just one word, or were you looking for many occurrences? How was that implemented?
Just the occurrence of one of the keywords, and any topic could be under two, or any response could fall under multiple topics. But one of the reasons that I didn't do automated topic modeling, where it kind of tells you the topics that are in there rather than you specifically asking, was because within the context of some of the surveys we assess, the topics are somewhat restricted so that there aren't a clear, like the survey may be specifically with regard to how do you feel about teleworking or COVID, or, what do you think about your leadership or your supervisor? So because the surveys are already somewhat specific in nature, I didn't think that automated topic modeling would be able to separate out distinct topics within that.
No, totally makes sense. And you actually got endorsed from Michael Kearney, who said, this is how I would recommend doing topic modeling. So awesome.
Great.
Let's see, any other questions? Awesome. Do you have any plans on extending this, or maybe, changing the visualization in any way, or implementing maybe like some like more interactive, like Plotly kind of stuff?
Yeah, so I plan to implement more charts, some to do with, the timing of when they responded so that they can see, they get the majority of negative responses within the first 5 days of a survey being released versus the tail end. So we can enhance kind of some of the things that we're looking at. And then I also wanted to enable some further topic modeling and kind of have the tool suggest, like, we're seeing a lot of, topics relating to this, or kind of suggesting, but not necessarily implementing that by itself. I think
Boss, you did it again. So I'll say real quick, let me jump in real quick. Julia, you should, after you're done scanning your screen, scroll up because there's lots of positive feedback and also questions for you to look at.
Oh, great. I'll try to answer those in the chat then.
Awesome.
Thank you, everybody. It's been an honor to present this. You guys are all obviously very familiar with R, so it's nice to be among people who love it as much as I do.
Great. Thanks so much, Julia. All right. So Katie, I'll be emceeing kind of our last talk here before our break coming up. Hopefully you guys stick around for this one because I know it's going to be great. So next up we have Pete Gordon. So Pete Gordon is CTO at Aviso. I actually had the pleasure of working with Pete for quite some time. And Pete is truly passionate about the internet and continues to kind of grow his knowledge in a variety of domains, R included. Also really passionate about user experience, IT security, and building of applications and all things internet, as he will talk to us about on his talk topic today. Today, he'll be talking to us about R and Plumber and how they are free and provide APIs for all. So Pete, if you want to go ahead and share your screen or your face, either or. Excited to
can you hear me okay? I don't think I can share my face. I'm trying in Zoom. It doesn't seem to be working. So
okay,
let's see if we can get my screen up there.
Oh, we got the screen.
And you got the audio going.
Maybe.
Can you hear me okay?
We can hear you. I have not heard the video yet because it's not playing.
Okay, there's no video. It's just me talking. That's what I meant by audio. Too bad I can't share my face. Actually, it's better for all of you if I don't share my ugly mug, probably. So sorry about that. Hopefully tonight I see you at the after party and we can meet face to face. So thanks everybody for allowing me to do this and kind of put this on. Thanks to the organizers and the sponsors too. It's a great event. Let me start by just saying that I am not a statistician. And I'm not really even an R programmer. I'm just a software guy with an information systems background from Ohio State, some software engineering background, and I surround myself with people that know R and the stats side of the world much, much better than I do, like yourself and like the organizers here. So, but I'm going to share with you something that I know. And it's going to be about web services and cloud computing. And I'm going to take you through kind of an internet journey in web services, cloud computing, and the R programming environment and how to do it, even for free. Free. So yeah, this is me. And let's talk about web services. So web services, APIs, HTTP that runs the world is our glue, right? It holds together the websites that we traverse. It holds together the deep applications that we do on the internet. It holds together those beautiful shiny apps that you put together on your local machines and maybe even into Shiny Apps IO or other places on the internet for all to experience. HTTP, the Hypertext Transfer Protocol, is it. And within that HTTP environment is this other thing that I love, this JSON stuff. And I'm looking for grins on people's faces as I mention this, because JSON seems to have a love and hate relationship in the statistician community from my experience. Some want to stay away from it and say, why don't you give me a CSV? And others seem to be embracing it. But JSON is what kind of runs these web services over HTTP and has given us this programmatic world of the internet. So JSON, JavaScript object notation, and that's right, I'm talking about JavaScript in a SatRdays conference because I can't not talk about JavaScript. So I'm going to talk about consuming web services versus creating web services, all right? So maybe some of you are familiar with this package, HTTR. Maybe there's others. This would be consuming those web services. And you can see the get and post that they call out. There's others. These are methods in HTTP that you're doing all the time on the internet as you surf it or as you create code in R that could consume data. So go get the data or go post maybe even authentication headers in order to retrieve some data, to do some fitting of a model against, or to add some data, to create more features against. And this would be consuming web services in HTTR. But I'm going to talk about creating web services and try to take us to another level. So maybe some of you guys are familiar with Flask on the Python side. I know somebody brought up Plumber earlier today during a talk and asked about it. But I'm going to talk about Flask and Plumber a little bit here, and I'm going to talk about them interchangeably. And why? Because when you're creating a web service, you are basically owning that web server that's going to run your code and produce your results over HTTP. And Flask and Plumber are interchangeably that opportunity or that library, right, that you can bring into your programming environment to be able to create a web service. So when you talk about Flask and you talk about microservices down here I'm highlighting, or you talk about Plumber and you talk about creating a web API, these are interchangeable terms, right? You're basically creating a function that you were going to make available over the internet, all right? It might only run locally on your machine and nobody can get to it, but you're doing it. You're creating an internet web service. And eventually, you're going to make it available for all to use and consume, all right? And the way we do that is we do it through cloud computing, all right? And cloud computing has this term that computer scientists tend to have a love-hate relationship with called serverless. And in serverless, I'm going to search it here for you so you can see, you know, I've got somebody that's using the same terms. In serverless, it's also referred to as function as a service. And this was kind of the first way that cloud computing services started to make available us writing our own code inline up in AWS and in Google Cloud Platform. And you could write in your programming, in a programming language, and even inline and deploy that, that function. So over here, I got Google Cloud Platform going. And let's say we want to do a serverless function. It's called Cloud Functions in Google Cloud. It's called Lambda Functions in AWS. And I come in here to create a new function, and I take a look, and I say, okay, I want to use my favorite programming language. And I find out I got .NET and C#, I got Go and Node.js, I got Python and PHP and Ruby. I even have Java out here. I've heard before equated to like a 17th century symphony, like Java is. But I have no R. And what am I going to do? So maybe I can go over to AWS and I can check it out. And I look at that list and you know what? I got no R there either. And I'm stuck. I'm like, you know, R is the best programming language I could ever use for this. But Google Cloud and AWS have basically stopped me from using R. So what is a man to do? Well, a man is to come into the world of containers and Dockers. And what Dockers are, for those, I know some here have used them, some are familiar with them, others are not. But Dockers and containers come out of a Linux container standardization that started, I don't know, some 10 plus years ago or what, probably more. And Docker is an implementation of that also. And it allows you to create an operating system and a full runtime environment like a computer and package it up. So in Google Cloud, there is an ability to take a Docker container and deploy it so it runs as an API. And they do it in a thing called Cloud Run, all right? And I'm gonna show you kind of a project that will allow you to take a R project and wrap it up with Plumber and deploy it into Google Cloud Run so that it only costs you when somebody actually makes that HTTP request to consume that API that you've deployed. So if I've completely like lost my tabs and my order because That's just how scattered I am. So here we are in a repo on mine. You can go out here, check it out. And it's going to take you, thanks to these guys at Medium, who originally did it at T-Mobile, and originally did kind of a Cloud Run deployment, but I simplified it here in this repo. And what I'm going to do is it's going to take you through steps. I'm going to skip some of the steps because I recommend that you go through the Python environment right here. And you can see the same thing that I just said about the quick starts and Google Cloud and all the programming languages here except R. And if there's one other here that you would like to do, I recommend you do it. And what this will do is this will take you through the steps to use gcloud command line SDK and get your Google Cloud Platform console working so that you can authenticate against it and you can use it locally with gcloud. And then you can run it and make sure it works, all right? And that will then bring you over to the questions of building and deploying. So let me show you what you're using in Google Cloud, all right? So in the background here, I've got my project up and running. And in RStudio locally, all right? And you can see these same files here, this Docker file. I'm gonna take you through it. Actually, while I do that, I'm gonna go ahead and do a build. So this command right here, gcloud, this is our command line for the Google Cloud SDK running locally, right? So this is how we use gcloud. And there's only like one other command that you'll probably have to use on here besides help. That'll be 2 commands. But the other command is auth login. And what that'll do is, actually, I'll go ahead and do it so you can see it. And what it'll do is it'll prompt you for your Google Cloud authentication, all right? And you'll just run through, log in, allow the SDK to have access, and these will be your permissions to be able to do Google Cloud, right? And on the command line. And then we're gonna do a build, not a run, a build. And what we're building here is this GCR.io. And I'm going to show you that in just a second, but this is a Google Cloud registry. And what it does is it puts our Docker file, it runs it and puts our Docker container up in the Google Cloud. This right here is our project that we're running in Google Cloud. This is the name of our registry. All right. So we're going to go ahead and run that. While it's running in the background, I'll kind of show you the Google Cloud interface and kind of talk about what's going on. So what I mentioned here was Google Cloud Registry. And we're going to go down a bit to this guy. It's actually Container Registry is what it is on Google Cloud. And that's where our images are going to be. You can see where I've uploaded before, and I've uploaded multiple times. And this is our Docker container up here. And you know what? It doesn't do much when it's just up here like this. Because what we got to also do is we got to make that Docker container available, not as a cloud function. Remember, we can't do cloud functions because they don't let us do R. So we're going to get around that by using Cloud Run. And this is where we're going to actually deploy and run it. So let's go back to R, see how it's doing. Still working here, but it's going to be done in just a moment, hopefully, because I'm running short on time. And we should see it as a registry once it's done. And then I'm going to kind of skip steps because it's going to work it in the background. We'll go into our Cloud Run Plumber once it's deployed. And then this URL right here, we're not using authentication. We could if we wanted, especially since we have all of the R Plumber environment available to us. We could use the headers for authentication. We could do basic authentication or a bearer token against it. But what this would do is open in a new window our R code, right? And our endpoint, which in this case is to predict the pedal length. It passes in the pedal width and we start hitting it, and all of a sudden we start executing against, there it is, 10, 5. We start executing against our R code up on Google Cloud Run. And the beauty of this is not just that our R code is up and running in Google Cloud as an API, but also that this Cloud Run scales to 0. And so that means you can put this up on the Google Cloud Run and it will not credit or charge anything to your account until it's being hit. And there's a baseline of how many times it can be hit for free. And it is scaling to 0, which actually, from what I understand, AWS doesn't even provide in their Elastic container offering. So let's go back. Let's make sure that completed. It did. We're going to go now and hit the run. And once that completes, it'll make that same API that we just did. We're going to set it to East 1, which is our region. And that is Google Cloud Run and R and free APIs for all to consume and use. So I wanted to take you on the internet journey, web services and APIs, love R on the Google Cloud platform. Thank you so much for attending, paying attention, and allowing me to do this. I will share that for more Google love in Central Ohio, I'm also involved with GDG Columbus and Ohio Dev Fest, which we last at our conference in 2019 before the pandemic. You all are invited always. So thanks for your time.
Wow, Pete, thank you. I didn't know where you were headed when I saw the tabs, and that was more than I could have ever imagined or hoped for. So a few questions here. So one question was, do you still have the UI that Swagger offers available when you're using Plumber or something like that?
Yeah, what a great question. I think the answer to that is yes, you do. If you are, I thought you had to generate them into an endpoint. I don't believe I have them available on mine. I think they are on the same port. So I think it is just the docs endpoint for the Plumber calls.
Awesome. Okay.
So I think the answer to that is yes. I think you can get them on the docs endpoint. I don't think that I have them in the ones that I've done.
Gotcha. Question from a boss here. Is there an AWS equivalent to Cloud Run? Does AWS have R support? Exclamation point.
I think that works. So the answer to that, the quick answer to that is I think not. Elastic containers, also referred to as, I think I've heard it called Fargate on the AWS side, will allow you to do very similar functions for Docker containers and scale them. But everything that I have seen and read does not allow them to scale to 0. So this is one distinction that I think is actually a really powerful distinction for software engineering and for development and kind of the bootstrapping that you can do with cloud computing. This is a distinction between Google Cloud and AWS that I'm surprised by. But a quick answer is I think no to AWS for scaling to 0. The answer is yes, absolutely for AWS doing containers and deploying containers that scale up from 1 to many. I find AWS's container environment to be pretty confusing, actually, personally. Any AWS experts out there, come to me and share your knowledge.
Good to know. That is a call for conversation at the happy hour with Pete Gordon. If you guys are going to stop by there, sponsored by Aware, 5:30. Pete, we got one more minute. I want to close this out with a tantalizing question here. What do you make of R not being on any of the lists you pulled up?
Oh, that's why I shared it. You know, I really don't know what to make of it exactly right now. When they started Cloud Functions or Lambda functions on the AWS side, Cloud Functions on the Google Cloud side, I think the list on Google Cloud was 3. I think it was Java, Python, and Node.js, JavaScript. You can see that list that I brought up. They've expanded it. to include Go, that's big in Google's world, PHP, and even the .NET Core open source stuff. So why has R not come into play? I don't have an answer to that. The cloud computing companies, AWS and Google, seem to be slow off the mark towards R and the stats community.
All right. I appreciate that. Great job, Pete. Amazing talk. You do have one more question in the chat. We'll let you try to get to over break, wondering if we can replicate the same in Azure. So we'll let you handle that one on the break. Again, appreciate it. We're going to be on break until 3 o'clock here, where we close out with our keynote next. So please do not go away for the whole day. Definitely want to hear this one. Don't want to miss it. And don't forget to register for happy hour at the end of the day if you have not already. All right. Take care, guys. See you in a bit.
We're just going to get started here in a few minutes as people trickle back in for their keynote. Nick, if you want to go ahead and start sharing your screen, I can, but I'll introduce you around 3 p.m. Yeah, just a reminder, we are having a happy hour sponsored by Aware in Columbus at 5:30 p.m. tonight. You can sign up, join us. Yeah, so welcome back, everyone. It's been an awesome day, lots of great talks. We finally arrived at our keynote. I'm super excited about it. Nick Wan will be giving a talk on his experience with Sliced. If you guys don't know about Sliced, this is an amazing data science show that Nick has been running. Season 1 just happened. It's really gamifies data science and has some awesome things like different models, visualizations, golden features. I enjoyed watching it. I watched maybe five episodes and the finals. It was really awesome. They had a bunch of great prizes, and really looking forward to next season. It's actually hosted on this Twitch. I'm sure he's going to talk about this stuff. But without further ado, welcome, Nick. We're really excited to hear about you, hear your talk and about your experience with Sliced.
Thank you. Okay, everything's going. Everything looked good. Okay. I appreciate that introduction, and yeah, thank you for. Oh, what am I doing? Did this go? I hope. Maybe. Okay. We'll live with it. We'll see what happens. Okay. Anyway, I appreciate the invite to SatRdays. I actually don't really get a lot of invites, so it's really nice to be invited to something like this, and I appreciate everyone organizing everything. All the talks tonight were pretty amazing, so cool. Okay, this is telling me to move my windows away from the share screen, so I'm going to do that because I think it might not be looking so great right now. So if y'all were wondering who I was, I spent the last handful of months doing a show called Sliced, and so as a game show host, I've learned a lot about building a community from scratch, or mostly from scratch. And you might again be wondering, why would some random game show host person who codes in Python keynote a R conference? And I do believe that there's a lot of similarities between places that are doing things like the Saturday conferences and things like the mighty art community in general. There's a lot of different ways we can learn from community building and how to encourage each other and things we've learned along the way building communities. So if you've never seen one of these talks I've given, bear with me. But again, if those in chat not familiar with Sliced, Sliced is a show a lot like the Food Network TV show Chopped, and I do hope when this plays, let me make sure. Let me make sure this is here. Yeah, here we go. Okay. So it's a lot like the Slice, or it's like the Food Network show called Chopped. And if you're unfamiliar with the show Chopped. Okay, cool. It looks a lot like this.
Season of Chopped is going to be the best ever.
That was hard. So overwhelming.
Our mystery ingredient baskets are just out of this world.
What am I going to do with this? My mind goes blank.
Amazing characters, and yet also really great cooks.
This is what's going to make or break me.
It's anyone's game still.
And you only have 30 minutes.
I'm worried about time.
I think people have no idea how hard Chopped is.
I'm panicking, I'm sweating, I'm going crazy.
Chopped, the new season premieres April 6th on Food Network.
Hey, sorry, Nick. You
Yeah.
have kind of an echo. You have kind of an echo going on between.
I have an echo. Weird. Okay. How's this?
Yep, that's better.
Okay. Let me see. I think. All right. Can you still hear me if I talk?
Yep.
Okay. How about now?
That echoes.
Mm-hmm. Interesting. Okay, we could go with this. It's okay now, though, right?
Yeah, no echo.
Okay. So in terms of Sliced, it's the oh god, what's going on here? What did I do? This. This. Okay, something weird happened. And now I'm getting like all my OBS windows up here. Oh, wait, do I do this? Oh, yeah. Okay. Anyway, sorry about that, y'all. Technical difficulties, but at least for what Sliced is, the goal of Sliced is to basically be the same thing, except rather than giving people a mystery food basket, we give them a mystery data science basket. So they get data they've never seen before. And it looks a lot like this. So the episodes look like this. Please tell me, oh God, Jesus Christ. Can y'all hear this? No. Okay. Gosh, there's all like this like stuff that I share from our video stuff, but that's fine. We could go without it. So Sliced is for data scientists competing, and they compete with a blind data set, and they get graded on modeling. Predictive modeling. They have to do this all in 2 hours. They also have to generate data visualization. These things called golden features, which are basically feature engineering points. And at the end of the night, they do get voted on by chat. So chat gives out points to the contestant they believe is the best. So when we ran through this the first handful of times, a question that I used to get when I would tell people we ran this show would be like, do people actually watch this? And sure enough, they absolutely do. And it's actually pretty incredible the turnout we got, because even though the responses we would get, very much was in support of Slice, we actually didn't realize like how big it would have grown. So if you're unfamiliar with like TV show and TV ratings, like here, if we took a sample of like a different competitive STEM show, then it, here's BattleBots, and it typically comes out to be this like U shape, where the first episode is something that's, really highly viewed, and then it tips off throughout the season until some sort of playoffs or season finale at the end. And so when we looked at the stats for Sliced, we also get that same U pattern. So just like TV shows, we're seeing, the beginning of our season being well attended. It dips off in the middle, and then as we entered the playoffs and the season finale, we ended up seeing a big return of our viewership, and a lot of viewers watching. This is hours watched, because it's also people watching on demand. So we do this live. We did 12 episodes every Tuesday through the summer. And then we also had people watching when they couldn't attend live. So over 52% of a year watched in hours, which is pretty awesome. And, if anyone is interested, you could actually watch it all yourself over on the YouTube. So if you want to go find me on YouTube, we have all the episodes there in both uncut 2 to 3 hour versions, and also 15-minute versions if you are so inclined. So we have also currently trying to hit 1,000 subscribers before the end of the year. So subscribing is free if you want to go over there and hit subscribe. Something that our show has that most competitions don't have is you typically don't have the chance to play literally side by side by the people on the show. And because we were all hosting our data all through Kaggle, we actually were able to have people download the data just as if they were competing like the contestants, and they could also submit their submissions on Kaggle and compare, how they were doing with not just the people who were competing, like people like Ethan Douglas or the eventual season winner David Robinson, but they could also see how they were stacking up against the rest of the community who were competing, which led me to think, like, is it possible that maybe the submissions, similar to our hours watched here, would follow the same U pattern, because you would assume that the more people watching would also equate to or correlate with the more people submitting. But it turned out that that wasn't the case. So we actually don't see that same U pattern, which made me think, is there actually any correlation at all? And I would have been very shocked if there wasn't, because again, the more people watching, theoretically, the more people submitting. And it turns out there was actually a null correlation. So there tended to be this weird cut between our community of people who were entering and trying to play along with Slice, and also our viewers who were just spectating, right? So this led me to research more into communities and how we could treat, one, if these were two distinct aspects of our community, and two, if we could really treat them and foster and support them as we continued through Slice. So just for this talk, I wanted to make sure that I wasn't saying anything really silly. So I read a bunch of academic journal articles about online community building. And I came across this article, which had a really good literature review on what community is really defined as. And I thought this really made sense to me because there's so many aspects that Slice fits into here. Everyone has that shared purpose of data science or watching people compete doing data science. If you've watched an episode of Slice, you're in the club. People trying to share code or just watch for entertainment as other people code, trying to find each other through our Twitter hashtag or through the Discord or in the live chat, and just trying to enjoy the competition for either the entertainment sake of it, the professional development sake of it, the education of it, whatever it might be. That communal aspect of Slice really started growing just seemingly naturally. So that first question that I had about our community was, related to this, because I always thought that it was one community, but did we really have two distinct groups in our Slice community? And I had a lot of people tell me that when they were competing, they would look forward to Slice each week, but they didn't spend a lot of time in chat. And the reason they didn't spend a lot of time in chat is because they were trying to do the problem. And this is a real quote. Trust me, it is real. And the theory here makes sense, because if you're hands-on keyboard on one program, you're probably not hands-on keyboard on a different program. But I wanted to dive into that. So the first thing I did was take a look at all the chat logs. So I grabbed all the chat logs and I classified every player or every person in chat as the type of chatter they were. And so using quantile splits here, I just ended up cutting out these groups of chatters. And I believe this seems right. You have your people who don't really chat that much, and then you have people who are chatting all the time. And then again, I wanted to go forward with this idea with our differences in our community. And I wanted to know if it was truly the case that the people competing, who I'll refer to as challengers here, were different than our people who were not competing alongside the contestants, our spectators. And it was not significant through any of the groups except for the lurking group, so the people who were not sending any messages at all. And this is, again, should be unsurprising to find that as you are, in the depths of competing, coding things up, you're probably going to be chatting less, meaning you might not be chatting at all. So seeing an increase in lurkers for our challengers made sense to me, but they still maintained, depending on who you were, you still maintained some sort of presence in chat. And so with this, I felt like, yeah, maybe there are two groups in our community. And so why not, try to do the next thing, which makes sense. How do we grow and foster and support our two groups of people? Because they really do enjoy Sliced in two different ways, one being a lot more active and competitive, and another one being more cooperative and potentially passive. And so the first thing I wanted to focus on was making sure that the people who are messing around with the data each Tuesday alongside our contestants were really getting everything they needed. And so the things that they really enjoyed were things like code walkthroughs. So people posting their own code, sharing code out, reading contestant blogs, or watching contestant videos about how they walk through things, watching other people's vlogs, or hearing or reading about how other people approach things. I saw something on our bloggers about how someone tried to use like H2O's like AutoML stuff and ended up coming in second place or third place, and one of the Slice contestants beat them out. So all these different ways to approach Slice, our challengers really liked seeing all these different approaches. And it's not that they didn't like seeing chat. They actually, again, back to that quote, they wish that they were in chat. So they do find other ways to communicate. And one of the ways is through our Discord. So at the end of the night or into the next day, we actually end up seeing a ton of people talking about different approaches to the problem, how people got bigger or larger scores or smaller scores or whatever the score metric was, how they improved their model and what they did, what kind of packages they used, what kind of functions they were using. And it wasn't just on Discord, but it was also through Twitter. So we see people on Twitter talking about how they were doing modeling and what they did to improve their models and what they wish they did. So how do we keep that going? And one of the things was giving things away. So the things that we would give away would be things like, this is probably not going to work. Is this working? No. Okay. I tried. But the giveaway portion for our challengers was if they competed and they ended up being on the top of the leaderboard, like you could see here, all the way up here. So depending on if you were someone in chat, someone competing who wasn't a contestant, if you ended up having the best score at the end of the night, then we actually ended up sending you a NVIDIA Deep Learning Institute code, which is basically their, the version of Coursera or Udemy. And then also ended up sending you some Kaggle swag, which is affectionately known as Swaggle. So people ended up getting some sort of prize for participating in our competition and doing well. So incentivizing our community and keeping this kind of communal behavior was a good way to keep people coming back. But really, it wasn't necessarily the awards or giveaways that they were coming back for, but it ends up being actually the data sets. So, one of the stats I found was as submissions per participant. So as people submitted more submissions, you had 10 a night to submit your best model. And if people ended up submitting more, it ended up being an indication that the problem itself had many different ways to be solved, or a lot of different approaches could be done through feature engineering or through modeling. And so people ended up submitting a lot, which also correlated with the amount of hours watched. So as we gave more challenging data sets, it increased the submissions, and it also was more compelling content to watch. So the things that were really important to supporting our challenger group was encouraging them to seek out and post their own walkthroughs, promote and engage with people who are competing, and do that by talking to them, by giving them forums to communicate, and also incentivizing their participation through giveaways, and then striving to really put together really good, amazing data sets for them to play on each week. So that's our challenger group. So how did we foster and support our spectator group? And we found out that our spectator group was really creative. And so, here's like fan art that we saw over the course of the season. Someone did this cross stitch for our logo. Some of you might be in chat, by the way. Shout out to Marshall here. People ended up taking memes to a next level with Slice. So Afton created this like alignment chart of all the contestants. So we saw a lot of different things like this, and also memes just in our show as well. Like there a meme went around called "Why for Meg," which was about how Meg Risdall, my co-host, ended up giving people a lot of fours, a lot of 4 points for their data visualization. That's 4 points out of a total of 20 points that they could have earned. So, you know, a little Gordon Ramsay action there from Meg. We also saw a lot of tweets and we also saw a lot of messages, a lot like this, where people were talking about how they wish Slice was a little more mainstream because they would have loved to talk about you know, modeling and stats with their larger friends groups, and this ends up like hitting that intersection of not just competitive coding, which is more, it seems like a sport or it seems like an e-sport, but it also hits this intersection of like reality TV, right? You're watching people do this on a day-by-day basis. It's through the entire season. You're watching them and listening to them talk about how hard it was. They're tweeting about it. They're going on their own streams talking about it. So you really get this like connection that you would get from like someone on like The Bachelorette, or in this case, Love Island. I never thought that, you know, the thing that I would be most known for later in my life would be the intersection of reality TV and machine learning. But here we are. Another thing that people really enjoyed was just having it on the background, right? So people end up watching this, throwing it on the background, and it's just something that on a Tuesday night, you could listen in if you want, you could turn your head and do something else. It doesn't necessarily matter too much how you're using the content, so long as you're enjoying it, and it's treating it sort of like however you want, right? Like an actual sports event. You know, if you throw like a football game on in the background, you don't have to pay attention to it until like the good juicy parts. And Slice was a lot like that for a lot of people. So how do we foster this community of people who might be a little more passive? They aren't necessarily people actively trying to participate with the coding and submitting on the Kaggle and digging through the data themselves. One way we did it was through a hashtag giveaway through Twitter. So using our Sliced hashtag, anyone who was using this, we entered them into a random giveaway pool, and we ended up giving away this Omen by HP gaming bundle. And we also gave away NVIDIA Deep Learning Institute codes for just being active in chat. So if you're in chat, you know, saying hi or spamming emotes or whatever, we also gave away Deep Learning Institute codes, because we wanted, again, the people who are challengers to be seen similar to people who were spectators. That both sides are extremely important to our growth as a show. So ways we supported spectators. Making sure that the meme culture was there and growing that and highlighting that when people were sharing memes or sharing anything, whether it's just messages of support or fan art or whatever it might be. And then showing our support not just through retweets and quote tweets, but also through actual incentives. So giving things away, creating compelling, and then creating compelling broadcasts in general. So not just all about the code, but things that connect you a little more with the people coding. So interviews, fun intros that we did, different point structures if people wanted to see a little more competitiveness through not just modeling, but through data visualization, live look-ins, live interviews. So all of that together created that sliced flavor that a lot of people ended up seeing. So, I know I'm like almost running out of time here, but I do want to make sure we get to this idea that it's always difficult to form communities, even though Slice seemed so natural and easy. I do ask the question, why is it so hard to form communities? Because even though Slice seemed so perfect in terms of community building, this isn't the first time I've tried to build a community. This isn't the first time that I've attempted. And many communities came before this for me that ended up floundering or not being as large or compelling as Sliced was. So I wanted to make sure that I wasn't going to say anything about community and community building that was going to get me canceled. So I made sure to read, again, a lot of journal articles about community building, and a lot of them end up talking about these three big takeaways of how communities end up failing or how communities end up floundering. And a big one is intentionality of community. A lot of the time people will put together some content and they assume that the community will just grow, some sort of spontaneous fandom will appear, and they'll just find their way and make their own subreddits and make their own hashtags for it. And that's not necessarily true. So something we did with Slice was we had that Discord. We made sure that we had the intentionality with the hashtag that everyone used. We made sure we stuck to a schedule for the show. That way everyone could find each other and chat. And we made sure to incentivize a lot of these processes simply because that is what intention is. If you want to make sure your community is interacting, make those roads and make them very visible to communicate and to communicate through. And another thing that's really big is one-way communication, and how a lot of the time when you see a lot of people on different areas of Twitter, they might be posting like weird motivational quotes that end up getting a lot of like retweets and likes. It's like, okay, that's great. But then they're not really talking to the people that are following them, or they're not trying to interact too much with others in the community. It ends up getting like a little strange because it doesn't feel so much like a community. So one of these papers, Chang and Zaki, their 2020 paper, they actually go into this situation, which they call one-way communication, and people in communities that are one-way communicators end up having generally this concept of trying to elevate their own status in the community. So they don't really try to reach out to people because they want to be seen as a go-to source or some pillar of the community. But that ends up working against them because communities with too many one-way communications, you start to feel like you aren't really in a community, and you end up feeling like you're in this weird multi-level social media marketing scheme. So one-way communication really can get some people ahead, but for the most part, it really sours the pool of the community if you have too much of that. And then an expert beginner dilemma, which for those who are experts in the field or regulars in the community, they tend to get a lot more attention than people who are new to the community or beginners in the field. Tech is a lot like this, where people who are so ahead of the pack or so well known, they get all the interaction, and people on the outside looking in or trying to get into the community feel like they're just and not getting the attention, and they ended up like having anxiety over posting new things because they feel like they're going to be attacked or looked down upon, and they end up having feelings of animosity towards these creators, larger creators in the community, because they again are taking up all the attention when the people who really need it, like the people who are just entering the community or the beginners of the community, aren't getting it. So how do we bridge the gap of the expert to the beginner, the regular to the newcomer? And a lot of the time, community organizers and content creators will lean towards the regulars and begin to forget the newcomers. And that's really what keeps the whole engine going, is you need a lot of new people as well as strong support from the people who've been there. So things that I learned in terms of community building, I know I'm over, but I'll end with this. What I learned from Sliced in terms of community building are these things. Have something to bond over. Whether it's, you know, a crazy reality TV competition, data science style, or, you know, a journal club or a book club or a package, whatever it might be, have something that you can bond over. Make two-way communication easy. So it shouldn't always, you know, be someone shouting out through a megaphone, barking at the people in the community. There should really be interaction for content creators, community organizers, and community members about how to develop the community and maybe maneuver the content in certain ways to make it more inclusive to everyone who's joining the community. Have multiple avenues of communication. So on Slice, we have not just our live chat on Twitch, but we also have YouTube and YouTube comments. We also have our Discord. We also have the Twitter hashtag. So many different ways of communication. And, you know, people end up liking many ways of communicating, if not, you know, some people are really only can do one. Like we have people in different time zones who can't attend live. So their communication ends up coming through other ways that aren't specifically live. So having multiple avenues of communication is really important for your community. Be prepared and willing to troubleshoot your community. So when you feel like things are becoming more one way, or you don't feel like the interactions you used to have are there, dig into why and talk to your community members. Maybe it's something you need to do for the community, like, you know, ask me anythings or anything like that. Also, you know, maybe the community wants different content. So maybe the things that you're doing, maybe you're going away from what people in the community, you know, were there initially for. And then the thing that's the most hard to conceptualize is the idea of the content community feedback loop. So as you put content out there, the community will take it, they will react to it, and that reaction will give the content creator, you know, hopefully positive encouragement to do even more content. And sometimes the community leans on the content creator to get that reaction. And sometimes the content creator will lean on their community to get inspiration or direct their content in certain ways. And so you need that engine going, and it needs to be, you know, well-oiled, so to speak. So make sure that you have these avenues of communication and keep learning what makes your content community feedback loop firing. And last but not least, you know, a great message here from Nori. She wrote in chat once while we were writing this this talk, community plus data science equals poggers. Which is true. You know, it's sometimes, you know, like me, I got pretty lucky with Sliced, and everything sort of fell together perfectly for community and data science. But, you know, a lot of these tips, they would have really helped me with my previous community building projects. And I do wish, and I do challenge the people on this call and watching this stream to take some of these tips and go out into your communities and try to improve your communities. Because, you know, a lot of these tips can go a long way, especially now that if you're more aware that some of these things can really help breathe more life into your community and really help bridge gaps where you might not have known that there were gaps. So, you know, if you're in something like SatRdays, or if you're in like subreddits of R, or if you're doing things like Tidy Tuesday, or if you're in larger art communities, take some time to talk with your community organizers and see what might be lacking there, and see how you could patch that up for them. And without conferences, without communities, we wouldn't have conferences like this, and life in general would be far less poggers. So if you want to find me, I'm very, very much over time. I'm sorry about that, but places you can find me: Twitch, that's NickWan_data_sci, or you can find me on YouTube or Twitter at NickWan. And again, I'm trying to get to 1,000 subs by the end of the year. So subscribing is free on YouTube. You just got to go there and hit subscribe. But I do appreciate y'all inviting me. I hope we can take this information and build upon the community y'all have built here, and let's build communities positively together.
Nick, that was awesome. Thank you so much. Really enjoy your passion in community building. My first question to you actually is, it's kind of interesting, there's always been kind of, at least when you first start in the data science field, there's always this Python R, bifurcation. And I think as you get more experience, you realize that, yeah, they both are powerful tools in many different ways. And, actually, if you gain expertise in one, it's quite suitable for doing all sorts of different data science tasks. I'm interested if you felt that you needed to manage that relationship at all in Sliced, or was it kind of just the data science community coming together, and just like, our Python doesn't matter, both of them can get after this machine learning stuff and do some great stuff?
Yeah, obviously, the lines are definitely drawn. There are people who are fanatics about both languages. I never had to police that. In fact, a lot of the time we encouraged, light banter about, one language over another, because it was just something that already existed. And if that's how people wanted to, be spirited about the competition, that was great. There were some people who kind of took it a little too far. But just like in any sport, there are people who sometimes take the seriousness of their team too far. Sometimes they take the game itself too far, and that's okay, because that does indicate this sort of level of passion or excitement that the community does have, either around Python or around R. And surprisingly, there's actually, of the 16 contestants that we had on Slice, 12 of them were R users. So Python was actually very underrepresented in Slice. So I am seeing the ramifications of that now in my regular streams. I basically stream to only R people, which is strange because I only code in Python. But again, I think that does show a lot of the indication of content people are seeking. It might not be language based a lot of the time. It just might be, programming general or machine learning in general.
Awesome. Yeah, we have a question from Afton on YouTube. He says, do you have any recs on how to root out bad actors in your communities early before they start to cause trouble, while still balancing that against being empathetic to potential misunderstandings?
Yeah. And shout out to Afton. Hey. It's true that for every community you do get trolls. For every community you're going to have people who are actors in bad faith. It's hard to identify them, especially when they're coming for a particularly neutral reason, like machine learning or programming. Personally, I tend to troll the trolls. I do enjoy using trolls as content to basically show what not to do, and a lot of my chat does get that, and I do think it is an education of the community you try to build. But obviously, that is a lot of people maybe don't like that approach. My personal opinion is the mods that you have and the kind of community you want to build, if anyone is going against whatever those tenets feel like to you, just ban. It's okay to ban. And it's okay to time out. I've timed out people for like a week, and that's usually like my default timeout now is like, yeah, come back in a week, and if you're still here, you really like the content, then be a good faith actor. So I think there are some ways to maybe use negative reinforcement to your advantage, but in my opinion, incentivizing or promoting people who do good actions is really important. Not just highlighting people who do good things, but highlighting the actions that they do. So make sure you point that out as much as possible, because if that's a way that your community can get attention from you, then that's something that they're going to try to do more often. So highlight good actions would be another way to combat bad actors.
Yeah, I think that's really good advice and good solutions. Does anyone from the participants want to ask Nick a question, or I have a couple more questions, so we'll let. Well, I'm wondering, I'm wondering about season 2 and wondering like how you become a candidate. Is there a certain level, like can you be a complete amateur? Do you have to be an expert? And then also, yeah, let's start there.
Okay. So yeah, season 2, planning hasn't quite started yet. We do have thoughts of doing off-season sliced events. So we're thinking about doing sliced in-person events at conferences. So nice. Yeah, so hopefully when we put all that together, we'll be able to share that out as well. But full-on season 2, we're going to hopefully start planning that in a month or so. And the same process that we used for season 1 really helped. So there is a problem set on our Notion website. If you search sliced Notion, I'm sure you'll be able to find our website. And it is, it shouldn't take you more than an hour, but it basically will skill check all the things that we see in Slice that are important to have. And so that's one way to apply, but just, shooting me or Meg a message either through the email or on Twitter or in one of our chats. If we know you're interested, we'll follow up with you when we get closer to the date for sure, because strangely enough, there's actually not a lot of people out there who want to do sliced. They find it extremely intimidating. And in my opinion, the thing that really broke down those walls for us was seeing how, D-Rob isn't the top person every night, and in the season he won 2 of his 4 nights, so he is beatable, and people who a lot of people look up to, like Julia Silgi or Jesse Mostback or Ethan Douglas, these folks in the community are great modelers and great data scientists, but in the 2-hour format they are beatable because it is such a small time window to do, a really comprehensive data science. So they do have to pick and choose their avenues. And yeah, that's what makes it a lot of fun, I feel.
Awesome. Anything else for Nick?
I see Eric jumped on the video. I just want to say shout out to my Cincy dude. Yeah.
That was a lot of fun, Nick. Really good.
Thanks, Eric. I liked yours in the morning, man.
All right. I think I'll let John or Katie lead the closing. But yeah, we really appreciate you, Nick. It was awesome having you. And maybe, I actually was thinking maybe it'll have maybe one, but if we ever do this in person, it would be amazing to have Sliced as like a little 1 hour action. So that'd be really cool. But
yeah, let me know. All right,
awesome.
y'all. Thanks for having me.
See ya.
Thanks so much, Nick. You can go ahead and stop sharing your screen. Great. All right. Thank you, everyone, for staying till the end. Just some final announcements before we end the day. So first of all, thanks to all our sponsors. So Aware is sponsoring the happy hour. Jumping River has also made a donation. And then TCC, the Tech Community Coalition, have handled all the accounting and just made this very doable for us co-organizers. I want to thank all the speakers today, all the attendees for spending the Saturday with us and giving us all these good questions and your attention. I did the book draw, okay, and the winner, the second one is Pete Gordon. So congrats, Pete. We'll be in contact to get you the book from George Mount. Let's see here. Oh, so this live stream, which you should have found a link to, you can go watch this unedited live stream whenever you want, jump around. But we are our co-organizer Bernie, who unfortunately had to leave early, so he's not here right now. But he's going to edit these. That's why we're trying to do those pauses between. He's going to edit them and post them individually. We will send out Eventbrite. We'll send out to the speakers so everyone can go and see the talks they want to go and see again. And we also will encourage the speakers, if you have slides that if you'd like to share the content with users, with the attendees, please post on the YouTube, like, here's a link to my slides, or here's a link to my GitHub repo. That'll be an easy way. If someone remembers your talk, they go there, they'll see the resource. Let's see. Okay, so the happy hour is happening. So if you're in the Columbus area, it's at the Walrus. If someone wants to, one of my coworkers can throw it in the chat again. People want to register last minute, but please try and make it. And hopefully next year, the world will be in such a condition that we can all come together for an actual conference and happy hour all across Ohio. I'm looking forward to it and hoping that will happen. Was not planning on doing 2 virtual ones in a row, but I'm really glad we pulled it off. And so with that, I'm going to go back to my malfunctioning computer and end this live stream. So thanks, everybody, and hope to see you next year.